Beneath layers of rock, something lies hidden. Silent, forgotten worlds. Civilizations lost to time, older than humanity itself. What if our species wasn't the first to rule Earth? Across the planet, clues emerge. Strange artifacts, baffling structures, hints of beings who walked here long before us. Scientists confront evidence that defies explanation, rewriting our history, piece by astonishing piece. Could an ancient civilization, erased by catastrophe, still whisper through stone and soil? Perhaps Earth's true history is darker and more wondrous than we ever imagined. Archaeologists define civilization through several key characteristics that indicate a complex, organized society. These features typically include the development of urban centers, where large populations live in close proximity. Such settlements often feature monumental architecture, like temples, palaces, or public buildings, showcasing advanced construction techniques and social organization. A hallmark of civilization is the presence of social stratification, with distinct classes or hierarchies emerging within the population. This often leads to specialized labor, where individuals focus on specific tasks or professions, moving beyond simple subsistence farming. Writing systems are another crucial element, allowing for record-keeping, communication, and the preservation of knowledge across generations. Civilizations also exhibit sophisticated economic systems, including trade networks that extend beyond local regions. They often develop standardized forms of currency or exchange. Additionally, civilizations typically have complex religious or belief systems, which are often intertwined with political power structures. Technological advancements, particularly in agriculture and resource management, are also key indicators of civilization. These might include irrigation systems, food storage methods, or the ability to exploit and process natural resources on a large scale. All these elements combine to create societies that are more complex and interconnected than earlier human communities. Human civilization as we know it stretches back approximately 12,000 years. This period, known as the Holocene epoch, began at the end of the last ice age and marked a significant shift in human development. During this time, our ancestors transitioned from nomadic hunter-gatherer lifestyles to more settled agricultural communities. The earliest known cities emerged around 10,000 years ago in regions like Mesopotamia, between the Tigris and Euphrates rivers. These early urban centers, such as Jericho and Çatalhöyük, represent the beginnings of complex societies with specialized labor, social hierarchies, and organized religion. As we move forward in time, we see the rise of great ancient civilizations like those in Egypt, India, and China. These societies developed sophisticated writing systems, monumental architecture, and complex social structures. The invention of writing, which occurred around 5,000 years ago, marks a crucial point in human history, allowing for the recording and transmission of knowledge across generations. It's important to note that while 12,000 years may seem like a long time, it represents only a tiny fraction of human existence on Earth. Our species, Homo sapiens, has been around for roughly 300,000 years, with most of that time spent as hunter-gatherers before the advent of agriculture and settled societies. Archaeologists rely on a variety of key indicators to identify and study ancient civilizations. One of the most important is the presence of architectural remains. These can range from the foundations of simple dwellings to monumental structures like temples, palaces, or fortifications. The scale and complexity of these buildings often reveal much about the society's level of technological advancement and social organization. Another crucial indicator is the presence of artifacts, which are objects made or modified by humans. These can include tools, weapons, pottery, jewelry, and artwork. The materials used, the craftsmanship involved, and the styles employed all provide valuable insights into the civilization's technological capabilities, trade networks, and cultural practices. Written records, when present, are invaluable to archaeologists. These can take the form of inscriptions on stone, clay tablets, papyrus scrolls, or other durable materials. Such records often provide direct information about a society's language, beliefs, political systems, and historical events. Archaeologists also examine evidence of food production and consumption. This includes agricultural tools, irrigation systems, food storage facilities, and animal bones. The types of crops grown and animals raised can reveal much about the climate, environment, and dietary habits of the ancient civilization. Additionally, the presence of trade goods from distant regions can indicate the extent of the civilization's economic and cultural connections with other societies. Distinguishing between natural formations and potential signs of intelligent design requires careful observation and analysis. Scientists employ several key principles when examining structures or phenomena to determine their origin. One crucial factor is complexity coupled with specificity. Natural processes can create intricate patterns, but they often display a degree of randomness or repetition. In contrast, signs of intelligent design might exhibit precise, non-random arrangements that serve a clear purpose. For instance, the hexagonal shape of honeycomb cells is a result of natural processes, while the precisely arranged stones of ancient monuments point to deliberate construction. Another important aspect is the presence of recognizable components or technology. Natural formations typically consist of materials found in their immediate environment, shaped by forces like erosion or geological processes. Potential artifacts of intelligent design might incorporate elements that appear out of place or demonstrate a level of engineering beyond natural occurrences. Context also plays a significant role in this differentiation. Scientists consider the surrounding environment and the likelihood of natural processes creating the observed formation. They look for signs of tool marks, symmetry, or patterns that are inconsistent with known natural phenomena in the area. This approach helps researchers avoid mistaking unusual but natural formations for signs of intelligence while remaining open to the possibility of artificial structures in unexpected places. Mythology serves as a crucial window into the beliefs, values, and worldviews of ancient civilizations. These stories and legends provide valuable insights into how our ancestors interpreted the world around them and made sense of natural phenomena they could not yet explain scientifically. Ancient myths often reflect the social structures, cultural norms, and ethical standards of the societies that created them. They reveal how people viewed their relationship with nature, the divine, and each other. For example, creation myths from various cultures offer glimpses into how different societies conceptualized the origins of the universe and humanity's place within it. Mythological tales also preserve historical events and cultural practices, albeit in a stylized form. While not always factually accurate, these stories can contain kernels of truth about real events, people, or places. Archaeologists and historians often use myths as starting points for their investigations, leading to discoveries that corroborate elements of these ancient narratives. Furthermore, mythology has influenced art, literature, and philosophy throughout history, shaping cultural identities and continuing to resonate in modern times. By studying these enduring stories, we gain a deeper appreciation for the complex tapestry of human thought and imagination that has evolved over millennia. Pop culture and science fiction have significantly shaped public imagination about pre-human civilizations, often blending fact with fantasy. Movies, books, and television shows have popularized ideas of advanced ancient societies, like Atlantis or extraterrestrial visitors influencing early human development. These fictional portrayals have sometimes led to misconceptions about actual archaeological findings and historical evidence. Science fiction has particularly fueled speculation about highly advanced prehistoric societies possessing technology far beyond their time. This has occasionally resulted in pseudoscientific theories gaining traction, such as the notion that the pyramids were built by aliens or that ancient cultures had access to electricity or advanced flight. However, these creative interpretations have also sparked genuine interest in archaeology and ancient history among the general public. This increased curiosity has led to greater support for scientific research and exploration, even if initial interest was based on fictional premises. Many people have been inspired to learn more about actual ancient civilizations after being introduced to the topic through entertainment media. While these influences can sometimes muddy the waters of historical understanding, they have also encouraged scientists to communicate their findings more effectively to the public. Archaeologists and historians now often engage with popular media to dispel myths and share accurate information about pre-human societies, helping to bridge the gap between scientific knowledge and public perception. Several fascinating theories propose the existence of advanced civilizations that may have predated humans on Earth. One such theory suggests the possibility of a technologically advanced society existing millions of years ago, often referred to as the Silurian Hypothesis. This concept explores whether an industrial civilization could have risen and fallen long before humans, leaving little to no trace due to the vast passage of time. Another intriguing idea is the potential for ancient astronauts or extraterrestrial visitors influencing early human development. Proponents of this theory point to unexplained archaeological findings and similarities in ancient cultures worldwide as evidence of otherworldly intervention. While lacking scientific consensus, these ideas continue to captivate the imagination of many. Some researchers have also proposed the existence of advanced prehistoric human civilizations that were wiped out by cataclysmic events. The hypothesis of a lost civilization predating the last ice age, sometimes associated with the mythical Atlantis, has inspired numerous archaeological expeditions and scientific debates. Though evidence remains elusive, the concept of a technologically sophisticated society existing thousands of years earlier than currently accepted challenges our understanding of human history. These theories, while controversial, prompt us to question our assumptions about the past and consider the potential for undiscovered chapters in Earth's long history. They remind us that our planet's story is vast and complex, with many secrets yet to be uncovered. Earth formed approximately 4.5 billion years ago during the early stages of our solar system's development. This age has been determined through various scientific methods, including radiometric dating of ancient rocks and meteorites. As the solar system coalesced from a vast cloud of gas and dust, Earth gradually took shape through a process of accretion, gathering more material over time. The young Earth was a very different place from the world we know today. It was a molten, inhospitable sphere, bombarded by asteroids and comets. Over millions of years, the planet cooled and developed a solid crust. The oldest rocks found on Earth's surface are nearly 4 billion years old, providing tangible evidence of our planet's ancient origins. Scientists continue to refine their understanding of Earth's age through ongoing research and improved dating techniques. The 4.5 billion year figure represents our current best estimate, based on a wealth of geological and astronomical evidence. This vast timescale serves as a foundation for understanding the long and complex history of our planet's evolution. Earth's history is divided into distinct geological periods, each marking significant changes in our planet's development. The story begins with the Precambrian, a vast expanse of time covering roughly 90% of Earth's history. During this era, the planet cooled, continents formed, and the first simple life emerged. Following the Precambrian came the Paleozoic era, which saw the explosion of complex life forms. This period includes the Cambrian, when most major animal groups appeared, and the Carboniferous, known for its lush forests that later formed coal deposits. The Paleozoic ended with the devastating Permian extinction, wiping out most species on Earth. The Mesozoic era followed, famously known as the Age of Dinosaurs. It encompasses the Triassic, Jurassic, and Cretaceous periods. This era saw the rise and fall of these iconic creatures, along with the emergence of mammals and flowering plants. The Mesozoic concluded with another mass extinction event that eliminated the dinosaurs. Our current era, the Cenozoic, began about 66 million years ago. It includes the Paleogene, Neogene, and Quaternary periods. During this time, mammals diversified and humans evolved. The Quaternary period, which we are in now, has been marked by ice ages and the rise of human civilization, showcasing how geological processes continue to shape our world. Earth's continents have undergone a remarkable journey over millions of years, constantly shifting and rearranging themselves across the planet's surface. This process, known as plate tectonics, has dramatically altered the face of our world. Around 250 million years ago, all of Earth's landmasses were joined together in a single supercontinent called Pangaea. This massive landmass began to break apart about 200 million years ago, splitting first into two large continents, Laurasia in the north and Gondwana in the south. As time progressed, these continents continued to fragment and drift. Gondwana split into what would become Africa, South America, Australia, Antarctica, and India. Laurasia broke apart into North America and Eurasia. The movement of these continental plates was slow but relentless, driven by convection currents in Earth's molten mantle. This continental dance continues today. North America is moving away from Europe, widening the Atlantic Ocean by about 2.5 centimeters each year. Meanwhile, India is slowly colliding with Asia, pushing up the Himalayan mountains in the process. These ongoing movements shape our planet's geography and will continue to do so far into the future. The search for Earth's earliest life forms takes us on a journey deep into our planet's distant past. Scientists have uncovered fascinating evidence of ancient microorganisms in rocks dating back nearly 4 billion years. These microscopic fossils, known as microfossils, provide tantalizing clues about the emergence of life on our young planet. One of the most significant discoveries comes from the Nouveau-Guitou greenstone belt in Quebec, Canada. Here, researchers found tiny filaments and tubes in rocks estimated to be between 3.7 and 4.2 billion years old. These structures closely resemble those created by bacteria living near hydrothermal vents in the deep ocean today, suggesting similar life forms may have existed in Earth's primordial seas. Another crucial piece of evidence lies in ancient stromatolites found in Western Australia. These layered rock formations, some dating back 3.5 billion years, are believed to have been created by photosynthetic microorganisms. The presence of these structures indicates that life had not only emerged, but had already evolved the ability to harness sunlight for energy. Chemical signatures in ancient rocks also provide compelling evidence for early life. Scientists have detected carbon isotope ratios in graphite from Greenland, dated to 3.7 billion years ago, that are characteristic of biological processes. This suggests that life was already influencing Earth's carbon cycle at this early stage, leaving its mark in the geological record. Earth has experienced 5 major mass extinction events throughout its long history. These catastrophic periods saw the loss of a significant portion of plant and animal species, reshaping the planet's biodiversity each time. The most well-known of these events occurred at the end of the Cretaceous period, about 66 million years ago, when an asteroid impact led to the demise of the dinosaurs. The earliest of these events, known as the Ordovician-Silurian extinction, took place roughly 445 million years ago. Following this, the late Devonian extinction occurred about 375 million years ago. The most severe of all was the Permian-Triassic extinction, often called the Great Dying, which happened around 252 million years ago and wiped out nearly 96% of marine species. The Triassic-Jurassic extinction, occurring roughly 201 million years ago, paved the way for dinosaurs to dominate the Earth. Finally, the aforementioned Cretaceous-Paleogene extinction marked the end of the age of dinosaurs and the beginning of the age of mammals. While these 5 events stand out as the most significant, Earth has experienced numerous smaller extinction events throughout its history. Today, many scientists argue that we are in the midst of a sixth mass extinction, driven primarily by human activities such as habitat destruction, pollution, and climate change. Throughout Earth's history, several catastrophic events have triggered mass extinctions, reshaping life on our planet. One of the most well-known culprits is the asteroid impact that occurred 66 million years ago, marking the end of the Cretaceous period and the reign of the dinosaurs. This massive collision unleashed global devastation, causing widespread fires, tsunamis, and climate change that affected ecosystems worldwide. Other mass extinctions have been linked to intense volcanic activity, such as the eruptions that created the Siberian traps at the end of the Permian period. These volcanic events released enormous amounts of greenhouse gases, dramatically altering Earth's climate and ocean chemistry. Rapid climate shifts, whether towards global warming or cooling, have played a significant role in several extinction events, disrupting food chains and habitats on a massive scale. While these cataclysmic events decimated Earth's biodiversity, the question of whether they could have wiped out an advanced civilization is intriguing but speculative. Our current understanding suggests that no such civilization existed during these ancient extinctions. However, if a technologically advanced society had been present, many of these events could have posed existential threats. An asteroid impact or supervolcano eruption would likely overwhelm even a sophisticated civilization's defenses, potentially leading to societal collapse. It's worth noting that modern humans have only been around for a fraction of Earth's history, emerging long after these major extinction events. Our species' adaptability and technological prowess might provide some resilience against similar catastrophes, but the sheer scale of these past events serves as a sobering reminder of nature's power to reshape life on Earth. Scientists employ a variety of ingenious methods to reconstruct Earth's ancient environments, piecing together clues from the distant past. One key approach involves analyzing sedimentary rocks, which form layers over time and trap evidence of past conditions. These rocks contain fossils of plants and animals that lived millions of years ago, providing insights into ancient ecosystems and climates. Another crucial tool is the study of ice cores extracted from polar regions. These frozen time capsules contain trapped air bubbles and particles that reveal information about atmospheric composition and temperature from thousands of years ago. Similarly, scientists examine tree rings, coral reefs, and lake sediments to uncover patterns of climate change over long periods. Geochemical analysis plays a vital role in this detective work. By measuring ratios of certain elements and isotopes in rocks, fossils, and sediments, researchers can determine ancient temperatures, ocean chemistry, and atmospheric conditions. This information helps paint a picture of Earth's past environments, from lush tropical forests to icy glacial periods. Advanced technology has revolutionized the field of paleo-environmental reconstruction. Techniques such as computer modeling and high-resolution imaging allow scientists to create detailed simulations of ancient landscapes and ecosystems. By combining these various methods, researchers continue to refine our understanding of Earth's long and dynamic environmental history, shedding light on how our planet has changed over millions of years. Dinosaurs ruled the Earth for over 160 million years, evolving into a vast array of species with diverse characteristics. While they developed many remarkable adaptations, there is no evidence that any dinosaur species evolved human-level intelligence. The brain-to-body size ratio, known as encephalization quotient, is often used as a rough indicator of intelligence. Even the most intelligent dinosaurs, like Troodon, had much lower encephalization quotients compared to modern mammals. Their brains were primarily devoted to processing sensory information and controlling bodily functions, with less capacity for complex problem-solving or abstract thought. However, it is important to note that intelligence can take many forms. Some dinosaurs likely possessed cognitive abilities well suited to their environments and lifestyles. For instance, pack-hunting dinosaurs may have developed social intelligence for coordinated hunting strategies. Herbivorous species might have had excellent spatial memory for locating food sources across vast territories. If dinosaurs had not gone extinct and continued to evolve for another 65 million years, it is impossible to predict what cognitive capabilities they might have developed. The emergence of human-like intelligence in primates was the result of specific evolutionary pressures and environmental factors, which may not have occurred in the same way for dinosaurs. If dinosaurs had developed an advanced civilization, the evidence left behind after millions of years would be subtle but potentially detectable. Geological processes and time would have erased or transformed most obvious signs, but some traces might persist. One key indicator would be unusual concentrations of metals and rare earth elements in rock layers from the dinosaur era. Advanced technology requires mining and refining these materials, which could leave lasting geochemical signatures. Scientists might find anomalous deposits or unexpected elemental ratios in sediments from that time period. Fossilized remains could also provide clues. Advanced dinosaurs might have modified their bodies or developed specialized anatomical features not seen in other fossil specimens. Paleontologists could potentially uncover dinosaur fossils with unnatural bone structures, signs of surgical interventions, or even cybernetic enhancements preserved in mineral form. Lastly, artificial structures or their remnants might endure. While buildings would likely crumble, foundations or underground facilities could leave persistent patterns in rock formations. Satellite imagery and ground-penetrating radar might reveal geometric anomalies or large-scale land alterations that defy natural explanations, hinting at the forgotten works of a long-lost dinosaur civilization. The physiology of dinosaurs would have significantly impacted their potential for technological development had they continued to evolve and not gone extinct. Dinosaurs, particularly the larger species, had relatively small brains compared to their body size. This limited brain-to-body ratio would have posed challenges for complex problem-solving and tool use, which are crucial for technological advancement. Many dinosaurs also lacked manipulative appendages like hands or fingers, which are essential for crafting and using tools. The theropod dinosaurs, including species like Tyrannosaurus rex and Velociraptor, did have arms and clawed hands, but these were often small and less dexterous compared to primate hands. This physical limitation would have made it difficult to create and manipulate objects with precision. Furthermore, the energy requirements of large dinosaurs might have hindered technological progress. Many dinosaurs spent a significant portion of their time foraging for food to sustain their massive bodies. This constant need for sustenance could have left little time or energy for activities beyond immediate survival, such as developing tools or exploring new concepts. However, it is important to note that some smaller, more agile dinosaur species, particularly those in the theropod lineage that eventually led to birds, might have had better potential for technological development. Their relatively larger brain-to-body ratios and more manipulative appendages could have provided a foundation for more complex behaviors and potential tool use, given enough time and the right evolutionary pressures. While no evidence supports the existence of intelligent dinosaur species, some scientists have speculated about the potential for advanced dinosaur evolution if the extinction event had not occurred. One theory suggests that certain theropod dinosaurs, particularly the dromaeosaurids like Velociraptor, might have evolved higher intelligence over millions of years. These dinosaurs already possessed relatively large brains for their body size and showed signs of complex social behavior. Another speculative concept explores the idea of a hypothetical dinosaur species called dinosauroid, proposed by paleontologist Dale Russell. This thought experiment imagined how a troodontid dinosaur might have evolved into a sapient, humanoid creature if given enough time and the right evolutionary pressures. The dinosauroid was envisioned with a larger brain, opposable thumbs, and an upright posture. Some researchers have also considered the possibility that hadrosaurs, known for their complex vocal structures, could have developed advanced communication skills and social structures over time. This speculation is based on the idea that complex vocalizations often correlate with higher cognitive abilities in modern animals. It is important to note that these theories remain purely speculative. And are not supported by fossil evidence. They serve more as thought experiments to explore evolutionary possibilities rather than scientific hypotheses. The actual course of dinosaur evolution, had it continued, would likely have been influenced by numerous unpredictable factors and may have taken entirely different paths. Paleontologists face a significant challenge when attempting to determine the intelligence levels of extinct species. Unlike living animals, which can be observed and tested, extinct creatures leave behind only fossilized remains. However, scientists have developed several methods to estimate cognitive abilities of long-gone species. One key indicator is brain size relative to body size, known as the encephalization quotient. By examining fossilized skulls and estimating brain volume, paleontologists can compare this ratio across different species and time periods. A larger brain relative to body size often suggests higher cognitive function, although this is not always a definitive measure. Another important clue comes from the structure of the brain itself. Advanced imaging techniques allow scientists to create detailed models of brain anatomy from fossilized skulls. This reveals the size and shape of different brain regions, providing insights into sensory processing, motor control, and potential problem-solving abilities. Paleontologists also look for indirect evidence of intelligence in the fossil record. Complex social behaviors, tool use, and adaptability to different environments can all indicate higher cognitive function. Fossils found in groups, signs of parental care, or remains of tools and shelters can suggest more advanced mental capabilities. By combining these various lines of evidence, scientists can make informed estimates about the intelligence of species that vanished millions of years ago. While no evidence has been found of dinosaurs using tools, it's an intriguing possibility to consider. The most likely candidates for tool use among dinosaurs would have been the theropods, particularly the dromaeosaurids like Velociraptor and its relatives. These dinosaurs possessed relatively large brains for their body size and had grasping hands with opposable digits, which could have potentially manipulated objects. Some modern birds, which are direct descendants of theropod dinosaurs, are known to use tools. The New Caledonian crow, for example, crafts and uses tools to obtain food. This suggests that the cognitive capacity for tool use might have existed in their dinosaur ancestors. However, it's important to note that tool use requires more than just physical capability. It also demands cognitive abilities such as problem-solving and understanding cause and effect relationships. While some dinosaurs may have had the physical attributes necessary for tool use, we cannot be certain about their cognitive capabilities. Without direct evidence in the fossil record, the idea of tool-using dinosaurs remains speculative. But as our understanding of dinosaur behavior and intelligence continues to evolve, we may one day uncover evidence that challenges our current perceptions of these ancient creatures. Imagine a world where dinosaurs evolved intelligence and built their own civilization. A dinosaur city would be a marvel of organic architecture, perfectly adapted to the needs of its massive inhabitants. Towering structures would rise from the ground, not built but grown from genetically modified plants. These living skyscrapers would be sturdy enough to support the weight of the largest sauropods, with wide corridors and spacious rooms to accommodate their bulk. The streets would be vast and open, designed for the thunderous footsteps of tyrannosaurs and the lumbering gait of stegosaurs. Instead of cars, we might see domesticated smaller dinosaurs used for transportation, with pterosaurs soaring overhead as a form of air travel. The city would likely be divided into different districts based on dinosaur types, with separate areas for herbivores and carnivores to coexist peacefully. Water management would be crucial in this prehistoric metropolis. Massive aqueducts and canals would crisscross the city, providing hydration for the enormous residents and their living buildings. parks and green spaces would be abundant, serving as grazing grounds for herbivores and ensuring a steady food supply for the carnivorous population. Technology in this alternate reality would be biological rather than mechanical. Instead of computers, we might see organic information processing systems, with dinosaurs interfacing directly with their environment through advanced sensory organs. This dinosaur city would be a testament to the potential of evolution, showcasing a world where reptiles, not mammals, became the dominant intelligent life form on Earth. Archaeological discoveries continue to reshape our understanding of human history, often presenting puzzles that challenge established timelines and theories. One intriguing find is the Göbekli Tepe complex in Turkey, a massive stone temple that predates agriculture and settled societies. This 12,000-year-old site suggests advanced organization and spiritual beliefs existed far earlier than previously thought, forcing archaeologists to reconsider the capabilities of hunter-gatherer societies. Another perplexing discovery is the Antikythera mechanism, an ancient Greek artifact often described as the world's first analog computer. This 2,000-year-old device, with its intricate gears and astronomical calculations, demonstrates a level of technological sophistication that was not thought to exist until much later in history. Its complexity raises questions about the extent of ancient Greek scientific knowledge and engineering skills. The Nazca lines in Peru present yet another archaeological enigma. These enormous geoglyphs, only fully visible from the air, depict various animals and geometric shapes across the desert floor. Created between 500 before Common Era and 500 Common Era, their purpose and the methods used to create such precise, large-scale designs remain subjects of debate among researchers. Equally puzzling are the stone spheres of Costa Rica, hundreds of nearly perfect stone balls ranging from a few centimeters to over 2 meters in diameter. Their purpose, method of creation, and the reason for their placement across the landscape continue to elude archaeologists, challenging our understanding of pre-Columbian cultures in Central America. Scientists have proposed several explanations for the remarkably precise stone-cutting techniques observed in ancient megaliths. These massive stone structures, found in various parts of the world, continue to astound researchers with their level of engineering sophistication. One widely accepted theory suggests that ancient builders used a combination of simple but effective tools and techniques. These included copper chisels, bronze saws, wooden wedges, and abrasive sand. By wetting wooden wedges placed in small cracks, the expanding wood could split large stones along natural fault lines. Builders then shaped these smaller pieces using hammerstones and chisels, achieving impressive precision through patience and skill. Some researchers propose that ancient civilizations might have developed more advanced tools than previously thought. For example, evidence of tubular drills has been found in Egyptian quarries, suggesting the use of core drilling techniques. These drills, possibly made of copper or bronze and set with hard abrasive particles, could cut through stone with remarkable accuracy. Another intriguing theory involves the use of advanced knowledge of sound and vibration. Some scientists speculate that ancient builders might have used acoustic levitation or vibration techniques to move and shape large stones. While this idea remains controversial, it highlights the ongoing mystery surrounding these ancient construction methods and the ingenuity of our ancestors. The Antikythera mechanism is an ancient Greek artifact that has puzzled scientists and historians for over a century. Discovered in 1901 off the coast of the Greek island Antikythera, this intricate device is often called the world's first analog computer. Dating back to around 100 to 200 BCE, the mechanism consists of a complex system of bronze gears and dials. Its sophistication far surpasses what experts previously believed possible for that era, challenging our understanding of ancient Greek technology and astronomical knowledge. The device's primary function appears to be predicting astronomical positions and eclipses with remarkable accuracy. It could track the movements of the sun, moon, and planets, as well as calculate the timing of various Pan-Hellenic games. This level of complexity suggests a deep understanding of celestial mechanics that was thought to have been developed much later in history. One of the greatest mysteries surrounding the Antikythera mechanism is its origin and purpose. Who created it? Was it unique, or were there others like it? How was such advanced knowledge seemingly lost for centuries afterward? These questions continue to drive research and speculation, making the Antikythera mechanism a captivating subject in the fields of archaeology, astronomy, and the history of science. Researchers approach out-of-place artifacts with a combination of skepticism and rigorous scientific analysis. These objects, which appear to be more technologically advanced than expected for their historical period, often challenge our understanding of past civilizations. The first step in accounting for such artifacts is to verify their authenticity and context. Scientists use various dating methods, including radiocarbon dating and thermoluminescence, to determine the age of the object and surrounding materials. They also examine the site where the artifact was found, looking for signs of disturbance or later intrusions that could explain an object's unexpected presence. If an artifact is confirmed to be genuine and in its original context, researchers consider several explanations. One possibility is that our current understanding of that culture's technological capabilities is incomplete. Historical records are often fragmentary, and new discoveries can reveal previously unknown advancements. Another explanation could be trade or cultural exchange, as objects sometimes traveled far from their places of origin. In some cases, what appears advanced might be the result of chance or misinterpretation. Natural processes can create objects that resemble human-made artifacts, and our modern perspective might lead us to misunderstand the true purpose or sophistication of an ancient item. Researchers must remain open-minded while adhering to scientific principles, carefully evaluating all evidence before drawing conclusions about out-of-place artifacts. Throughout history, cartographers have created intriguing maps that seem to depict lands unknown to their time or even lost continents. One famous example is the Piri Reis map, drawn in 1513 by Ottoman Admiral Piri Reis. This map appears to show parts of South America and possibly Antarctica, despite being created long before the official discovery of the Antarctic continent. Some researchers argue that the map's accuracy suggests ancient seafarers had knowledge of these lands. Another notable example is the Zeno map, allegedly created in the late 14th century by Venetian explorers. This map shows a large island called Frisland in the North Atlantic, as well as other mysterious lands. While many scholars consider the Zeno map a 16th century forgery, it continues to fuel speculation about undiscovered territories. The Boache map, created by Philippe Boache in 1739, is yet another puzzling cartographic artifact. It appears to depict Antarctica without its ice cover, showing two distinct landmasses. This has led some to suggest that the map was based on ancient sources with knowledge of Antarctica's subglacial topography. These maps, along with others like the controversial Oronteus Phineus map, continue to intrigue researchers and enthusiasts alike, sparking debates about the extent of ancient geographical knowledge and the possibility of lost civilizations. The existence of ancient structures that appear to require advanced engineering has long fascinated historians, archaeologists, and the general public. While these monuments may seem beyond the capabilities of ancient civilizations, careful study reveals the ingenuity and resourcefulness of our ancestors. Many of these structures were built using techniques that, while not technologically advanced by modern standards, were highly sophisticated for their time. Ancient builders often employed simple machines like levers, pulleys, and ramps to move and position massive stones. They also developed clever construction methods, such as the corbelled arch, which allowed them to create stable structures without modern materials. The seeming impossibility of these feats often stems from our underestimation of human creativity and determination. Ancient civilizations devoted immense resources and time to these projects, sometimes working for decades or even centuries. They also possessed a deep understanding of mathematics, astronomy, and natural materials, which they applied to their engineering challenges. Furthermore, many of these structures were built incrementally, with techniques and knowledge improving over time. What we see today is often the culmination of generations of work and accumulated expertise, rather than a single, impossible feat of engineering. By recognizing the true capabilities of ancient peoples, we can appreciate their achievements without resorting to speculative explanations. Pseudo-archaeology often plays a problematic role in interpreting unusual findings or anomalies in the archaeological record. While mainstream archaeology relies on rigorous scientific methods and peer-reviewed research, pseudo-archaeology tends to make extraordinary claims without sufficient evidence. Proponents of pseudo-archaeology frequently latch onto unexplained artifacts or sites and construct elaborate theories involving ancient aliens, lost advanced civilizations, or supernatural phenomena. These interpretations can be alluring to the public, offering seemingly simple explanations for complex historical puzzles. However, such claims typically ignore established scientific knowledge and the cultural context of ancient societies. They often misinterpret or exaggerate the significance of genuine archaeological discoveries. This approach can mislead the public and detract attention and resources from legitimate archaeological research. Ultimately, while pseudo-archaeology may offer entertaining speculation, it fails to contribute meaningful insights to our understanding of human history and ancient cultures. Genuine archaeological anomalies are best investigated through careful excavation, analysis, and peer-reviewed studies rather than sensationalized claims. The legend of Atlantis is a fascinating tale that has captured human imagination for thousands of years. It originates from the ancient Greek philosopher Plato, who described Atlantis as a powerful and advanced island nation that existed over 9,000 years before his time. According to Plato, Atlantis was located beyond the Pillars of Hercules, which we now know as the Strait of Gibraltar. Plato portrayed Atlantis as a utopian civilization with remarkable technological achievements, grand architecture, and a complex social structure. The Atlanteans were said to possess great wealth and military might, allowing them to conquer parts of Europe and Africa. However, their hubris and moral decline eventually led to their downfall. The legend concludes with the gods punishing Atlantis for its wickedness, causing the entire island to sink into the ocean in a single day and night of misfortune. This captivating story continues to intrigue us for several reasons. First, it taps into our fascination with lost civilizations and the idea that advanced societies might have existed in our distant past. The notion that a highly developed culture could vanish without a trace sparks our curiosity and fuels speculation about hidden histories. Moreover, the legend of Atlantis serves as a cautionary tale about the dangers of excess and the potential consequences of technological advancement without moral guidance. It resonates with our modern concerns about environmental destruction and societal collapse, making the story feel relevant even in today's world. This timeless appeal, combined with the mystery surrounding its possible real-world origins, ensures that the legend of Atlantis continues to captivate our imagination, inspiring countless books, films, and scientific expeditions in search of the truth behind the myth. The concept of lost continents has captivated human imagination for centuries, and while many popular ideas about sunken lands are rooted in myth, there are some scientific theories that explore the possibility of submerged continental fragments. One such theory involves the idea of microcontinents, which are relatively small pieces of continental crust that have broken off from larger landmasses. Zealandia, a mostly submerged landmass in the South Pacific, is considered by many geologists to be a microcontinent that separated from Australia and Antarctica millions of years ago. Most of Zealandia lies beneath the ocean, with only small portions, including New Zealand and New Caledonia, remaining above sea level. Another area of scientific interest is the Kerguelen Plateau, a submerged landmass in the southern Indian Ocean. Some researchers suggest that this vast underwater region may have been partly above sea level at various points in Earth's history, potentially supporting plant and animal life. Plate tectonics and sea level changes play crucial roles in these theories. As continents drift and collide over millions of years, some areas may become submerged while others rise. Climate change and glacial cycles can also influence sea levels, potentially hiding or revealing land masses over time. While these scientific theories do not support the existence of mythical lands like Atlantis, they do offer fascinating insights into the dynamic nature of Earth's geology and the possibility of undiscovered submerged lands. Underwater archaeological discoveries have revealed intriguing structures off the coast of Japan and other locations around the world. Near the island of Yonaguni, Japan, divers have found a series of massive stone formations with sharp angles and flat surfaces. Some researchers believe these could be the remnants of an ancient civilization, potentially dating back thousands of years. The formations include what appear to be terraced structures, ramps, and even a pyramid-like feature. Similar underwater structures have been discovered in other parts of the world. Off the coast of Cuba, researchers using sonar technology have detected geometric patterns that resemble urban complexes. In the Mediterranean, near the island of Malta, divers have explored what some believe to be ancient roads and building foundations submerged beneath the waves. However, the interpretation of these underwater structures remains a subject of debate among scientists and archaeologists. While some argue that they are evidence of lost civilizations, others contend that they may be naturally occurring geological formations shaped by erosion and tectonic activity over millions of years. The challenge lies in distinguishing between human-made structures and natural formations that can sometimes resemble artificial constructions. Ongoing research and advanced underwater mapping technologies continue to shed light on these mysterious structures. As we explore more of our planet's underwater realms, we may uncover further evidence that could help resolve the debate surrounding these enigmatic formations and potentially rewrite our understanding of ancient human history. Geologists explain the formation and sinking of large land masses through the theory of plate tectonics. This fundamental concept in Earth science describes how the outer layer of our planet, called the lithosphere, is divided into several large plates that move and interact with each other over millions of years. The formation of large land masses, or continents, occurs through various processes. One key mechanism is the collision of tectonic plates, which can cause the Earth's crust to thicken and rise, forming mountain ranges and expansive land masses. Additionally, volcanic activity can contribute to the growth of land areas, as lava and ash accumulate over time to create new terrain. The sinking of large land masses, known as subsidence, can happen due to several factors. One common cause is the cooling and contraction of the Earth's crust, which can lead to a gradual lowering of the land surface. Another factor is the weight of sediment accumulation, which can cause the underlying crust to sink slowly over time. In some cases, the extraction of groundwater or minerals from underground can also result in land subsidence. Plate tectonics also explains how entire continents can appear to sink relative to sea level. As tectonic plates move and shift, some areas may experience uplift while others subside. This process, coupled with changes in global sea levels due to factors like ice ages and climate change, can give the impression of continents sinking or rising over geological timescales. Underwater archaeologists employ a range of sophisticated technologies to uncover the secrets of submerged cities. Sonar systems play a crucial role in these explorations, using sound waves to create detailed maps of the seafloor. Advanced multi-beam echo sounders can produce high-resolution, three-dimensional images of underwater structures, revealing the outlines of ancient buildings and streets hidden beneath the waves. Remote-operated vehicles, or ROVs, equipped with high-definition cameras and robotic arms, allow researchers to explore and document sites at great depths without risking human divers. These unmanned submersibles can transmit live video feeds to ships on the surface, giving archaeologists a real-time view of their discoveries. Magnetometers detect variations in the Earth's magnetic field caused by buried metal objects, helping researchers locate artifacts and structures made of iron or other magnetic materials. This technology can identify promising areas for further investigation, even when visual evidence is lacking. LiDAR, which stands for light detection and ranging, is increasingly used in underwater archaeology. This laser-based system can penetrate water to create detailed topographic maps of submerged landscapes, revealing features that might be invisible to other scanning methods. By combining these advanced technologies, scientists are piecing together the stories of long-lost cities, bringing ancient civilizations back to life from their watery graves. As our planet's climate continues to warm, rising sea levels pose a significant threat to modern coastal communities. But this phenomenon may have already erased crucial chapters of human history. There is compelling evidence to suggest that numerous ancient coastal civilizations could now lie hidden beneath the waves, their secrets waiting to be uncovered. During the last ice age, sea levels were much lower than they are today. As the ice melted and seas rose, many coastal areas where early humans lived became submerged. This gradual flooding would have forced communities to abandon their homes and move inland, leaving behind artifacts and structures that are now underwater. Underwater archaeology has already yielded tantalizing glimpses of these lost worlds. Off the coast of India, researchers have discovered the submerged city of Dwarka, believed to be over 9,000 years old. In the Mediterranean, divers have explored the sunken portions of Alexandria, including the legendary Pharos lighthouse. These findings suggest that many more archaeological treasures may lie hidden on the seafloor. The implications of submerged civilizations extend beyond archaeology. They provide valuable insights into how past societies adapted to changing sea levels, offering lessons for our own coastal communities facing similar challenges today. As technology advances, underwater exploration may reveal a wealth of information about our ancestors and their relationship with rising seas, reshaping our understanding of human history and coastal adaptation. The depths of our oceans hold countless secrets, and underwater archaeology has revealed some truly astounding discoveries. One of the most captivating finds is the ancient city of Pavlopetri off the coast of Greece. This submerged Bronze Age settlement, dating back nearly 5,000 years, provides a unique glimpse into the daily lives of our ancestors. Its well-preserved streets, buildings, and tombs offer an unprecedented look at urban planning from millennia ago. Equally fascinating is the discovery of Cleopatra's palace in Alexandria, Egypt. This once magnificent complex now lies beneath the waters of the Mediterranean, a victim of earthquakes and rising sea levels. Divers have recovered stunning artifacts, including colossal statues, sphinxes, and even pieces of Cleopatra's personal items, painting a vivid picture of the legendary queen's opulent lifestyle. In the cold waters off Sweden's Baltic coast, marine archaeologists uncovered the remarkably well-preserved wreck of the warship Vasa. This 17th-century vessel sank on its maiden voyage and remained hidden for over 300 years. Its near-perfect condition, complete with intricate wooden carvings and personal belongings of the crew, provides an unparalleled window into naval warfare and life in the 1600s. Another extraordinary find is the Antikythera mechanism, discovered off the Greek island of Antikythera. This ancient analog computer, dated to around 100 BCE, could predict astronomical positions and eclipses with remarkable accuracy. Its complexity has forced historians to re-evaluate ancient Greek technological capabilities, showcasing the advanced knowledge of our forebears. The ancient astronaut theory proposes that extraterrestrial beings visited Earth in the distant past, influencing human civilizations and technological development. Proponents of this idea suggest that advanced aliens interacted with early humans, sharing knowledge and potentially altering our genetic makeup. They argue that evidence for these encounters can be found in ancient artwork, texts, and architectural marvels that seem to depict or require technology beyond what was believed possible at the time. Supporters of the theory point to various artifacts and structures around the world as potential proof. These include the Egyptian pyramids, Stonehenge, and the Nazca lines in Peru. They claim that the precision and scale of these monuments indicate extraterrestrial involvement, as they believe early humans lacked the necessary tools and expertise to create such works. The theory also attempts to explain certain religious and mythological stories as misinterpreted accounts of alien contact. For example, some proponents suggest that gods described in ancient texts were actually extraterrestrial visitors, and that their advanced technology was perceived as divine power by early humans. While the ancient astronaut theory has captured public imagination and inspired numerous books and television shows, it is important to note that the scientific community largely rejects these ideas. Archaeologists and historians argue that there is no credible evidence to support the theory and that it undermines the ingenuity and capabilities of ancient human civilizations. Proponents of the ancient astronaut theory often view historical artwork and texts through a lens of extraterrestrial influence. They interpret various ancient artifacts, cave paintings, and religious scriptures as evidence of alien visitations in Earth's past. These theorists point to depictions of what they claim are flying saucers or beings in spacesuits in ancient rock art and paintings. They argue that certain intricate geometric patterns or unusually advanced technological representations in old artwork could only have been inspired by extraterrestrial encounters. In terms of ancient texts, proponents often reinterpret religious and mythological stories as accounts of alien interactions. They suggest that tales of gods descending from the sky, miraculous events, or advanced knowledge imparted to humans are actually descriptions of extraterrestrial beings and their technology. However, it is important to note that mainstream archaeologists, historians, and scientists generally reject these interpretations. They argue that these alternative explanations often ignore cultural context, misinterpret symbolic art, and disregard the creativity and capabilities of ancient human civilizations. Throughout history, people have speculated about extraterrestrial influences on ancient civilizations. One of the most frequently mentioned examples is the construction of the Egyptian pyramids. Some theorists argue that the precise engineering and massive scale of these structures suggest advanced knowledge beyond what ancient Egyptians should have possessed. Another often cited case is the Nazca lines in Peru. These enormous geoglyphs, only fully visible from the air, have led some to propose that they were created as landing strips or signals for alien spacecraft. The intricate designs and the mystery surrounding their purpose have fueled speculation about extraterrestrial involvement. The statues of Easter Island represent another puzzling archaeological site, often linked to alleged alien activity. The sheer size and weight of these monoliths, combined with the island's isolation, have led some to question how the native population could have created and transported them without outside assistance. Lastly, ancient religious texts and artwork are sometimes interpreted as evidence of alien contact. Descriptions of flying chariots in Hindu scriptures or unusual aerial phenomena in medieval paintings are often pointed to as potential records of extraterrestrial visitations. While these theories capture the imagination, mainstream archaeologists and historians generally attribute these achievements to human ingenuity and labor rather than alien intervention. Mainstream archaeologists and historians generally approach alternative theories about ancient civilizations with skepticism and caution. They rely on established scientific methods and evidence-based research to form their conclusions about the past. When presented with ideas that challenge conventional understanding, these professionals carefully examine the evidence and arguments put forth. Many archaeologists and historians emphasize the importance of peer-reviewed research and verifiable data. They often point out that extraordinary claims require extraordinary evidence. In cases where alternative theories lack substantial archaeological or historical evidence, mainstream scholars tend to dismiss them as speculative or pseudoscientific. However, the scientific community is not entirely closed to new ideas. When credible evidence emerges that challenges existing theories, archaeologists and historians are willing to re-evaluate their understanding. This process involves rigorous testing, analysis, and debate within the academic community. Over time, if new evidence consistently supports alternative explanations, mainstream views can shift. It is worth noting that the field of archaeology and history is constantly evolving. New technologies and methodologies often lead to fresh insights and discoveries. While mainstream scholars remain committed to established scientific principles, they also recognize the importance of ongoing research and the potential for new findings to reshape our understanding of ancient civilizations. The possibility of advanced extraterrestrial civilizations visiting Earth in the distant past has long captivated human imagination. While there is no conclusive scientific evidence to support this idea, it remains an intriguing concept that continues to fuel speculation and research. Our planet has existed for over 4 billion years, providing a vast window of time during which such visits could have theoretically occurred. The universe itself is approximately 13.8 billion years old, allowing ample time for civilizations to arise, develop advanced technologies, and potentially master interstellar travel. However, the challenges of interstellar travel are immense. The vast distances between stars, the limitations imposed by the speed of light, and the enormous energy requirements for such journeys present significant obstacles. Any civilization capable of overcoming these hurdles would likely possess technology far beyond our current understanding. If such visits did occur, they might have left behind evidence. Yet, despite extensive archaeological research, no unambiguous artifacts or traces of extraterrestrial technology have been discovered on Earth. This absence of evidence, while not conclusive proof against the idea, does raise questions about the likelihood of past extraterrestrial visitations. To conclusively prove or disprove the ancient alien theory would require extraordinary evidence, given the extraordinary nature of the claim. Definitive proof of extraterrestrial visitation in Earth's past would likely need to come in the form of indisputable physical artifacts of clearly non-human origin. This could include advanced technology far beyond the capabilities of ancient human civilizations, with materials or construction methods impossible to replicate with the tools and knowledge available at the time. Alternatively, the discovery of non-terrestrial DNA in ancient human remains or artifacts could provide compelling evidence for ancient alien contact. Clear and unmistakable depictions of extraterrestrial beings or advanced technology in ancient art or writing, corroborated across multiple independent cultures, might also lend strong support to the theory. On the other hand, disproving the theory conclusively is more challenging, as it requires proving a negative. However, comprehensive archaeological evidence showing the gradual development of human technologies and cultures without any unexplained leaps in knowledge or capability would significantly undermine the ancient alien hypothesis. Additionally, if we could account for all supposedly unexplainable ancient achievements through demonstrations of forgotten human ingenuity and techniques, it would leave little room for extraterrestrial intervention. Ultimately, the burden of proof lies with those making the claim of ancient alien visitation. Without concrete, scientifically verifiable evidence, the theory remains speculative at best. The ancient alien theory has significantly impacted popular culture and media, sparking imagination and debate across various platforms. This controversial idea suggests that extraterrestrial beings visited Earth in the distant past, influencing human civilization and technological development. Television has been particularly receptive to this concept, with numerous documentaries and series exploring alleged evidence of alien intervention. Shows like Ancient Aliens have gained substantial followings, presenting speculative interpretations of historical artifacts and structures as potential proof of extraterrestrial contact. The entertainment industry has also embraced ancient alien themes in movies, books, and video games. These works often blend historical settings with science fiction elements, creating narratives that captivate audiences and encourage them to question conventional historical explanations. While mainstream scientists and historians largely reject the ancient alien theory, its presence in media has undeniably shaped public discourse about human origins and the possibility of extraterrestrial life. This cultural phenomenon has led to increased interest in archaeology, ancient civilizations, and space exploration, demonstrating the power of speculative ideas to influence societal interests and discussions. Several ancient technologies stand out as remarkably sophisticated, challenging our assumptions about early human capabilities. The Antikythera mechanism, discovered in a shipwreck off the coast of Greece, is often called the world's first analog computer. Dating back to around 150 BC, this intricate system of gears could predict astronomical positions and eclipses with astonishing accuracy. In South America, the Incan city of Machu Picchu showcases advanced engineering techniques. Its precise stone construction, efficient drainage systems, and earthquake-resistant architecture continue to impress modern engineers. The city's design demonstrates a deep understanding of geology, hydrology, and structural principles. The Roman concrete used in structures like the Pantheon has puzzled scientists for centuries. This ancient material, more durable than many modern counterparts, has withstood the test of time for 2,000 years. Its composition, which includes volcanic ash, creates a self-healing property that prevents cracks from spreading. Ancient Baghdad batteries, clay pots containing copper cylinders and iron rods, suggest possible early experimentation with electricity. While their exact purpose remains debated, these devices from around 250 BC could potentially generate a small electric charge, hinting at sophisticated understanding of electrical principles long before their formal discovery. The construction of massive structures like the pyramids has long fascinated historians and engineers alike. Ancient Egyptians built these monumental tombs over 4,500 years ago using ingenious techniques and meticulous planning. Contrary to popular myths, the pyramids were not built by slaves, but by skilled workers who were likely well compensated for their efforts. These ancient builders used a combination of ramps, levers, and pulleys to move enormous limestone blocks into place. They quarried stone nearby and transported it using wooden rollers and sleds. One key to the pyramid's construction was the Nile River. During annual floods, the river would swell, allowing workers to float massive stone blocks on rafts close to the construction site. This significantly eased the transportation of heavy materials over long distances. The ancient Egyptians also possessed advanced knowledge of mathematics and astronomy, which they used to achieve the pyramid's precise alignment and near-perfect shape. Their sophisticated understanding of engineering principles, combined with a large and organized workforce, allowed them to create structures that continue to amaze us millennia later. The Nazca lines, etched into the desert plains of southern Peru, have puzzled researchers for decades. These enormous geoglyphs, some stretching over 1,000 feet in length, depict various animals, plants, and geometric shapes. Several theories attempt to explain their purpose and creation. One prominent theory suggests the Nazca lines served as an astronomical calendar. Proponents argue that the lines align with celestial bodies, potentially helping the ancient Nazca people track seasons and plan agricultural activities. This idea connects the geoglyphs to practical, everyday concerns of the civilization that created them. Another intriguing hypothesis proposes that the lines were part of water-related rituals. Given the arid climate of the region, some researchers believe the Nazca people created these massive designs as a plea to their gods for rain and fertile crops. The lines might have served as pathways for religious processions, with the images representing important elements of their cosmology and agricultural life. A more recent theory posits that the Nazca lines were the result of communal rituals. This idea suggests that the act of creating and maintaining these massive designs served as a unifying activity for the Nazca society, reinforcing social bonds and cultural identity. The scale and complexity of the lines would have required significant cooperation and shared purpose, potentially strengthening the fabric of their civilization. While there's no concrete evidence that ancient civilizations possessed advanced energy technologies beyond our current understanding, the possibility continues to intrigue scientists and historians alike. Some researchers have proposed theories about potential energy sources used in the distant past, though these remain speculative. One area of interest is the construction of massive ancient structures, like the pyramids of Egypt or the precisely cut stones of Machu Picchu. Some suggest that these feats might have required energy sources or technologies we haven't yet discovered. However, most experts believe these achievements were accomplished through ingenious engineering and vast human labor rather than unknown energy forms. Another fascinating example is the Baghdad Battery, a set of terracotta pots from ancient Mesopotamia that some believe could have been used to generate electricity. While this interpretation is disputed, it raises questions about the potential for early electrochemical knowledge. Ultimately, while ancient civilizations demonstrated remarkable ingenuity in harnessing known energy sources like water, wind, and animal power, there's currently no solid evidence for energy forms unknown to modern science. However, ongoing research and archaeological discoveries continue to shed new light on the technological capabilities of our ancestors, reminding us that there may still be much to learn about the past. Archaeological discoveries have revealed surprising evidence of sophisticated metalworking techniques in ancient civilizations. In ancient Egypt, for example, craftsmen were producing intricate gold jewelry and elaborate copper tools as far back as 3,000 years before the Common Era. These artifacts show a level of skill and precision that was once thought impossible for that time period. Even more astonishing are the iron pillars of ancient India, particularly the famous Delhi iron pillar. This massive structure, standing over 7 meters tall and weighing more than 6,000 kilograms, was forged in the 4th century and has resisted corrosion for over 1,600 years. Metallurgists are still amazed by the advanced techniques used to create such a rust-resistant iron alloy. In South America, the Moche civilization of ancient Peru demonstrated remarkable skill in copper smelting and gold working. They developed a technique called depletion gilding, which allowed them to create objects that appeared to be solid gold but were actually copper alloys with a gold surface. This sophisticated process involved selectively removing copper from the surface of the alloy, leaving behind a layer of pure gold. These examples challenge our understanding of ancient technological capabilities. They suggest that our ancestors possessed knowledge and skills that were far more advanced than previously believed, prompting us to reconsider the timeline of human technological development and the ingenuity of ancient civilizations. Ancient civilizations across the globe have left us with remarkable structures that demonstrate precise astronomical alignments. These alignments, found in monuments like Stonehenge in England, the Great Pyramid of Giza in Egypt, and various Mayan temples in Central America, continue to intrigue archaeologists and astronomers alike. One explanation for these alignments is the ancient people's deep connection to celestial events. Many cultures relied on the movements of celestial bodies to mark the passage of time, determine agricultural cycles, and guide religious practices. By aligning their structures with specific celestial events, such as solstices or equinoxes, they created a physical link between their earthly realm and the cosmos. The precision of these alignments suggests that ancient cultures possess sophisticated observational skills and a profound understanding of astronomical cycles. They likely used simple yet effective tools, such as shadow sticks and horizon markers, to track celestial movements over extended periods. This accumulated knowledge allowed them to predict and incorporate celestial alignments into their architectural designs with remarkable accuracy. It is important to note that while some alignments may have been intentional and significant, Others could be coincidental. Researchers must carefully analyze each site, considering factors such as the culture's astronomical knowledge, the structure's purpose, and potential alterations over time. By combining archaeological evidence with astronomical calculations, we can better understand the true intent behind these ancient alignments and gain insight into the scientific capabilities of our ancestors. Throughout history, humans have marveled at the achievements of ancient civilizations, often wondering if they possessed advanced technologies that have since been lost to time. One intriguing theory suggests that the ancient Egyptians might have used sophisticated lighting systems in their tombs and pyramids. Some researchers propose that they could have harnessed electricity through chemical batteries or even piezoelectric properties of quartz crystals, allowing them to illuminate the dark interiors of their monumental structures. Another fascinating speculation revolves around the construction techniques of megalithic structures worldwide. From Stonehenge in England to the massive stone blocks of Pumapunku in Bolivia, some theorists argue that ancient builders might have employed advanced acoustic levitation methods to move and position enormous stones with precision. While there is no concrete evidence to support this idea, it continues to captivate the imagination of many. The legendary lost city of Atlantis has also sparked numerous theories about advanced ancient technologies. Some speculate that the Atlanteans possessed clean energy sources, possibly harnessing the power of crystals or even developing early forms of nuclear energy. Others propose that they had mastered weather control or anti-gravity technology, allowing them to build magnificent floating cities. In South America, the incredible metalworking skills of ancient cultures have led to speculation about lost metallurgical techniques. Some researchers suggest that civilizations like the Incas might have possessed the ability to soften stone using plant extracts, allowing them to shape and fit massive blocks with astonishing precision. While these theories remain unproven, they continue to fuel our curiosity about the ingenuity and potential technological prowess of our ancient ancestors. Genetic research has revolutionized our understanding of human origins, providing a powerful tool to trace our ancestral lineage back through time. By analyzing DNA from modern humans and comparing it with ancient genetic samples, scientists can reconstruct the journey of our species across the globe. One of the most significant contributions of genetic research is the confirmation that all modern humans share a common African origin. This finding supports the out-of-Africa hypothesis, which posits that Homo sapiens evolved in Africa before migrating to other continents. Genetic studies have revealed that non-African populations carry only a subset of the genetic diversity found in African populations, indicating that these groups descended from a small number of individuals who left Africa tens of thousands of years ago. Genetic research has also shed light on the complex interactions between early humans and other hominin species. For instance, studies have uncovered evidence of interbreeding between Homo sapiens and Neanderthals, as well as with the mysterious Denisovans. This genetic mixing has left traces in the DNA of modern humans, with many people today carrying small percentages of Neanderthal or Denisovan genes. Furthermore, genetic studies have allowed scientists to estimate the timing of key events in human evolution, such as the emergence of different populations and their migrations across continents. This information, combined with archaeological and fossil evidence, provides a more comprehensive picture of our species' history and helps us understand the genetic diversity we see in human populations today. The fossil record provides a wealth of evidence about human evolution, offering glimpses into our ancient past. Over millions of years, our ancestors underwent significant changes, transforming from ape-like creatures into modern humans. Fossils of early hominins, our ancient relatives, reveal a gradual shift towards bipedalism, the ability to walk on two legs. This adaptation freed up hands for tool use and carrying, a crucial step in human development. Skeletal remains show changes in hip structure, spine curvature, and foot shape, all indicating this transition to upright walking. As we examine younger fossils, we see a trend of increasing brain size. The cranial capacity of our ancestors grew over time, allowing for more complex cognitive abilities. This expansion is particularly noticeable in the frontal lobe area, associated with higher-order thinking and social behavior. The fossil record also documents the spread of early humans across the globe. Remains found in Africa, Asia, and Europe show how our ancestors migrated and adapted to different environments. Tools found alongside these fossils provide insight into the technological advancements of early humans, from simple stone tools to more sophisticated implements. This evidence paints a picture of human evolution as a complex, branching process rather than a straight line, with multiple species of hominins coexisting at various points in history. The possibility of an earlier intelligent species on Earth is a topic that sparks curiosity and debate among scientists. While our current understanding of evolution and the fossil record does not support the existence of a previous technologically advanced civilization, there are indeed gaps in our knowledge of Earth's history that leave room for speculation. The Precambrian era, which accounts for roughly 85% of Earth's history, is particularly mysterious. This vast stretch of time, spanning from Earth's formation about 4.5 billion years ago to the emergence of complex life forms around 540 million years ago, has left relatively few fossils. The scarcity of evidence from this period makes it challenging to completely rule out the potential for earlier forms of intelligence. However, it is important to note that any hypothetical earlier intelligent species would likely have left some traces of their existence. These could include geological evidence of resource extraction, chemical signatures of industrial processes, or even artifacts that might have survived the ravages of time. The absence of such evidence, despite extensive geological exploration, suggests that if an earlier intelligent species did exist, they either did not reach a level of technological advancement comparable to our own, or were extraordinarily adept at concealing their presence. While the idea of a lost intelligent species is intriguing, current scientific consensus holds that humans are the first and only technologically advanced civilization to have evolved on Earth. Nevertheless, the search for knowledge continues, and future discoveries may yet reveal surprising chapters in our planet's long and complex history. Scientists have proposed several theories to explain the sudden leaps in human cognitive abilities observed throughout our evolutionary history. One prominent hypothesis suggests that genetic mutations played a crucial role in these cognitive advancements. These mutations may have led to changes in brain structure and function, allowing for more complex thought processes and problem-solving abilities. Environmental factors also likely contributed to these cognitive leaps. As early humans faced new challenges in changing environments, their brains adapted to meet these demands. This process of cognitive adaptation may have been accelerated by periods of rapid climate change, forcing our ancestors to develop new skills and ways of thinking to survive. Another important factor in human cognitive development was social interaction and cultural transmission. As human groups grew larger and more complex, the need for advanced communication and cooperation increased. This social pressure may have driven the development of language and abstract thinking, further enhancing our cognitive capabilities. Technological advancements, such as the creation and use of tools, also played a significant role in shaping human cognition. The ability to make and use tools required and fostered more sophisticated mental processes, creating a positive feedback loop that continually pushed our cognitive boundaries. These combined factors likely contributed to the remarkable leaps in human cognitive abilities that have shaped our species over time. The term missing link in human evolution refers to a hypothetical transitional fossil that would bridge the gap between humans and our earliest ape-like ancestors. However, this concept is somewhat outdated in modern paleoanthropology. Scientists now understand that human evolution is not a linear progression, but a complex branching tree with many different species evolving simultaneously. Rather than searching for a single missing link, researchers have discovered numerous fossils that illuminate the path of human evolution. These findings include species like Australopithecus, afarensis, Homo habilis, and Homo erectus, each representing important stages in our evolutionary history. One of the most significant discoveries was the fossil known as Lucy, an Australopithecus afarensis specimen found in Ethiopia. Lucy lived about 3.2 million years ago and showed a combination of ape-like and human-like features, providing crucial insights into early human ancestors. While there is no single missing link, ongoing research continues to fill gaps in our understanding of human evolution. New fossil discoveries and advanced genetic analysis techniques constantly refine our knowledge of our species' complex evolutionary journey. The quest to understand our origins remains an active and exciting field of scientific inquiry. Genetic engineering has not played a direct role in human development as we know it today. Our species, Homo sapiens, evolved through natural processes over hundreds of thousands of years without any intentional manipulation of our genetic code. However, the concept of genetic engineering raises intriguing possibilities for the future of human development. In recent decades, scientists have made significant strides in understanding the human genome and developing tools to modify genetic material. These advancements have led to discussions about the potential applications of genetic engineering in human biology. Some researchers envision a future where genetic modifications could be used to eliminate hereditary diseases, enhance physical or cognitive abilities, or even extend human lifespan. While these possibilities are theoretically exciting, they also raise complex ethical and societal questions. The idea of altering the fundamental building blocks of human life is controversial and fraught with potential consequences that are not yet fully understood. Currently, most countries have strict regulations governing genetic engineering in humans, limiting its application primarily to medical research and therapeutic purposes. It is important to note that while genetic engineering has not shaped our evolutionary past, our increasing understanding of genetics and the development of gene editing technologies may influence human development in the future. As we continue to explore this field, society will need to grapple with the implications and responsibilities that come with the power to potentially alter the course of human evolution. While the scientific consensus supports human evolution from earlier primates, some alternative theories have gained attention. One such idea is the ancient astronaut hypothesis, which suggests advanced extraterrestrial beings visited Earth in the distant past and influenced human development. Proponents argue that certain ancient structures and artifacts show signs of advanced technology beyond what early humans should have possessed. Another unconventional theory is the aquatic ape hypothesis. This concept proposes that human ancestors spent a period living in aquatic environments, leading to adaptations like reduced body hair and a layer of subcutaneous fat. Supporters claim this explains unique human traits not shared by other primates. Some researchers have proposed multi-regional origin theories, suggesting that modern humans evolved independently in different parts of the world from local, archaic human populations. This contrasts with the more widely accepted recent African origin model. These alternative theories remain highly controversial and lack substantial scientific evidence. Most experts in anthropology, genetics, and related fields continue to support the gradual evolution of humans in Africa based on fossil records and genetic studies. However, ongoing research and new discoveries continually refine our understanding of human origins. Climate changes have played a crucial role in shaping human history, often acting as a catalyst for the rise and fall of civilizations. Throughout the ages, shifts in temperature and precipitation patterns have directly impacted food production, water availability, and living conditions, profoundly influencing the fate of societies around the world. The collapse of the Akkadian Empire in Mesopotamia around 2150 BCE has been linked to a severe drought that lasted for 300 years. This prolonged dry spell led to crop failures and social upheaval. ultimately contributing to the downfall of one of the world's earliest empires. Similarly, the demise of the classic Maya civilization in Central America between 800 and 1000 CE coincided with a series of intense droughts which likely exacerbated existing social and political tensions. On the other hand, favorable climate conditions have also facilitated the growth of civilizations. The Roman Empire thrived during a period known as the Roman climate optimum, characterized by warm, wet, and stable conditions that supported agricultural expansion and population growth. This climate phase lasted from about 250 BCE to 400 CE, aligning closely with the rise and golden age of Rome. More recently, the Little Ice Age, a period of cooling that occurred between 1300 and 1800 CE, had far-reaching consequences for European societies. It contributed to crop failures, famines, and social unrest, influencing events such as the French Revolution. These historical examples underscore the profound impact that climate changes can have on human civilizations, shaping their development, expansion, and eventual decline. Earth's climate has undergone dramatic changes throughout its history, with periods of extreme heat and cold reshaping the planet's surface. These climate shifts could indeed have obscured or destroyed evidence of earlier civilizations, particularly if they existed in coastal regions now submerged by rising sea levels. During the last ice age, vast sheets of ice covered much of North America and Europe. As these glaciers retreated, they scoured the land, potentially erasing traces of any societies that might have existed before. The melting ice also caused sea levels to rise significantly, flooding coastal areas where early humans often settled. More recent climate events, such as the Younger Dryas period about 12,000 years ago, saw rapid temperature changes that could have disrupted or eliminated developing societies. This event, which brought a sudden return to near-glacial conditions in many parts of the world, coincides with the disappearance of many large animal species and could have had a devastating impact on human populations. While there is no concrete evidence of advanced civilizations predating our current historical record, the dynamic nature of Earth's climate and geology means we cannot rule out the possibility entirely. The search for such evidence continues, with new technologies allowing scientists to explore previously inaccessible areas, both on land and beneath the waves. The end of the last ice age, roughly 12,000 years ago, marked a pivotal moment in human history. As vast ice sheets retreated, they left behind a transformed landscape that provided new opportunities for our ancestors. This climatic shift ushered in the Holocene epoch, a period of relative warmth and stability that continues to this day. The changing environment had profound effects on plant and animal life, altering the resources available to humans. Melting glaciers created fertile river valleys and exposed land bridges, facilitating human migration and the spread of ideas. In regions like the Fertile Crescent, the warmer, wetter climate allowed for the cultivation of wild grains, setting the stage for the development of agriculture. This agricultural revolution was a cornerstone in the formation of settled communities. As humans transitioned from nomadic hunter-gatherer lifestyles to more permanent settlements, they began to domesticate animals and develop more complex social structures. These changes laid the groundwork for the emergence of the first cities and the rise of early civilizations in places like Mesopotamia, Egypt, and the Indus Valley. The end of the Ice Age also contributed to technological advancements. The need to adapt to new environments spurred innovation in tools, hunting techniques, and later, farming methods. This period of rapid change and adaptation set humanity on a path of accelerated development, ultimately shaping the foundations of modern civilization as we know it today. Scientists employ a variety of ingenious methods to reconstruct ancient climates, piecing together Earth's past like detectives solving a complex puzzle. One key approach involves analyzing ice cores extracted from polar regions. These frozen time capsules contain trapped air bubbles and particles that reveal atmospheric composition and temperature data stretching back hundreds of thousands of years. Tree rings provide another valuable source of information. By examining the width and density of annual growth rings, researchers can infer past temperature and rainfall patterns. In regions where trees are scarce, scientists turn to coral reefs, which form annual growth bands similar to tree rings, offering insights into ocean temperatures and chemistry. Sediment cores from lakes and oceans contain a wealth of climate data. These layers of accumulated material preserve pollen grains, microfossils, and chemical signatures that reflect past environmental conditions. By studying the composition and distribution of these elements, scientists can reconstruct temperature, precipitation, and even wind patterns from long ago. Fossil evidence also plays a crucial role in climate reconstruction. The presence of certain plant and animal species in the fossil record can indicate specific climate conditions, as organisms often have narrow environmental tolerances. Additionally, the chemical composition of fossils, particularly the ratio of oxygen isotopes in shells and bones, provides valuable temperature data from Earth's distant past. The possibility of an advanced civilization causing its own demise through catastrophic climate change is a sobering concept that resonates with our current environmental challenges. While we have no concrete evidence of such an event occurring on other worlds, the idea is not beyond the realm of scientific plausibility. An advanced civilization might develop technologies and industries that significantly alter their planet's atmosphere and climate systems. This could involve the release of greenhouse gases, deforestation, or large-scale manipulation of natural resources. As these changes accumulate, they could trigger feedback loops, amplifying the effects and potentially leading to runaway climate change. The consequences of such drastic environmental shifts could be severe. Rising temperatures might cause widespread crop failures, leading to food shortages. Extreme weather events could destroy infrastructure and displace populations. Melting ice caps could flood coastal regions, while changing ocean currents might disrupt global climate patterns. These cascading effects could strain the civilization's ability to adapt, potentially leading to societal collapse. This hypothetical scenario serves as a cautionary tale, highlighting the delicate balance between technological progress and environmental stewardship. It underscores the importance of understanding and respecting the complex systems that sustain life on a planet, reminding us of our own responsibility to address climate change and its potential consequences. Ancient civilizations demonstrated remarkable ingenuity in adapting to their climate challenges, leaving behind evidence that continues to impress modern researchers. In the arid regions of the Middle East, the Qanat system stands as a testament to advanced water management. These underground aqueducts, some dating back over 2,000 years, transported water from mountain springs to distant settlements, allowing agriculture to flourish in otherwise inhospitable environments. The Indus Valley civilization provides another striking example of climate adaptation. Archaeological excavations have revealed sophisticated urban planning with covered drains and advanced sewage systems. These innovations helped manage water during both monsoon seasons and dry periods, showcasing an understanding of seasonal climate patterns and the need for year-round water conservation. In South America, the Incan civilization developed an impressive technique known as terracing. By carving steps into steep mountain slopes, they created level surfaces for agriculture. This method not only increased arable land, but also prevented soil erosion and improved water retention, allowing crops to thrive in challenging mountainous terrain. The ancient Maya civilization in Central America constructed intricate water collection and storage systems. They built reservoirs and canals to capture and distribute rainwater, enabling them to sustain large populations in areas with limited natural water sources. These systems demonstrate a profound understanding of local climate patterns and the need for long-term water management strategies. Climate change poses significant challenges to archaeological discoveries and the preservation of ancient sites. Rising sea levels threaten coastal archaeological sites, potentially submerging valuable historical evidence beneath the waves. In some regions, increased rainfall and flooding could erode or damage exposed ruins. while in others, extended droughts might lead to the cracking and deterioration of artifacts and structures. Changing weather patterns also affect the tools and techniques archaeologists use. Ground-penetrating radar, a crucial tool for non-invasive site exploration, becomes less effective in overly dry or waterlogged soils. Satellite imagery, another vital resource for identifying potential dig sites, might be obscured by more frequent dust storms or changes in vegetation patterns. However, climate change is not solely a destructive force for archaeology. Melting glaciers and ice patches have revealed remarkably well-preserved artifacts and even human remains, such as Ötzi the Iceman found in the Alps. Coastal erosion, while threatening some sites, has exposed others that were previously hidden. These climate-driven revelations offer brief windows of opportunity for researchers to study newly uncovered historical treasures. Adapting to these changes, archaeologists are developing new technologies and methods. They are racing against time to document and preserve threatened sites using three-dimensional scanning and virtual reality reconstructions. Climate change is reshaping not only our planet, but also our approach to uncovering and understanding our ancient past. Archaeological evidence for extensive underground structures built by ancient civilizations is limited but intriguing. Some of the most well-documented examples come from Turkey, where the region of Cappadocia contains several underground cities. The largest, Derinkuyu, extends about 200 feet below the surface and could have housed thousands of people. These multi-level complexes included living quarters, storage areas, and ventilation shafts, suggesting they were designed for long-term habitation. In Italy, the ancient Etruscan civilization left behind an extensive network of underground tunnels and chambers. These structures, found primarily in central Italy, served various purposes, including drainage, water storage, and possibly religious ceremonies. Some of these tunnels stretch for miles, demonstrating the advanced engineering capabilities of this pre-Roman culture. Another notable example is the Hypogum of Hal Saflieni in Malta, a subterranean structure dating back to around 3600 BCE. This complex, consisting of interconnected chambers on 3 levels, is believed to have been used as a sanctuary and burial site. Its sophisticated design and acoustic properties have puzzled researchers for decades. While these examples provide concrete evidence of ancient underground structures, it is important to note that many claims of vast, undiscovered subterranean networks remain speculative. Ongoing archaeological research continues to uncover new information about the extent and purpose of these ancient underground spaces. Living underground might seem like an unusual choice, but for an advanced society, it could offer significant advantages. Deep beneath the surface, a civilization would be protected from harsh weather, extreme temperatures, and even cosmic radiation. This protection could be particularly valuable on planets with inhospitable surface conditions. Underground habitats could maintain stable temperatures year-round, reducing the need for heating and cooling systems. This energy efficiency could be a crucial factor for a society looking to conserve resources. Moreover, subterranean living spaces could be expanded more easily than surface structures, allowing for population growth without the constraints of limited land area. An advanced underground civilization might develop sophisticated tunneling technologies, creating vast networks of interconnected chambers and passages. They could use advanced lighting systems to mimic natural sunlight and develop hydroponic or aeroponic farming techniques to grow food without soil. Water could be sourced from underground aquifers or through efficient recycling systems. However, such a lifestyle would present challenges. The lack of natural sunlight could affect health and psychology, requiring careful management of artificial light and vitamin supplementation. Ventilation and waste management would also be critical concerns. Despite these hurdles, with sufficient technological advancement, an underground society could not only survive, but potentially thrive, hidden from view beneath the surface of their world. Complex cave systems with signs of intelligent design can often be explained through natural geological processes and human intervention. Over millions of years, water flowing through limestone or other soluble rocks carves out intricate networks of tunnels and chambers. This process, known as karstification, creates stunning formations like stalactites and stalagmites that might appear designed. What might seem like intelligent design could be the result of ancient human habitation or use. Our ancestors often sought shelter in caves, leaving behind artifacts, paintings, and modifications that can be mistaken for intentional design. In some cases, modern humans have expanded or altered cave systems for tourism or scientific study, adding elements that appear planned or engineered. Some cave systems also show evidence of prehistoric mining activities. Ancient humans extracted minerals and metals from caves, leaving behind tunnels and chambers that might resemble purposeful design. These modifications, combined with natural formations, can create complex systems that seem too intricate to be the result of random processes. It's important to approach such observations with scientific skepticism. What appears to be intelligent design often reveals itself, upon closer investigation, to be the fascinating interplay of geological processes and human interaction with the environment over thousands of years. Beneath our feet lies a treasure trove of archaeological wonders, each telling a unique story of our past. One of the most captivating discoveries is the terracotta army in China. Thousands of life-sized clay soldiers, each with distinct features, stand guard over the tomb of Emperor Qin Shi Huang. This underground army, hidden for over 2,000 years, provides invaluable insights into ancient Chinese military practices and artistry. In the depths of Turkey, the underground city of Derinkuyu astounds archaeologists and visitors alike. This vast subterranean network could house up to 20,000 people, complete with living quarters, storage rooms, and even schools. The city's intricate ventilation system and strategic defensive features showcase the ingenuity of its ancient builders. Moving to Egypt, the Valley of the Kings continues to yield remarkable finds. In 1922, Howard Carter unearthed the tomb of Tutankhamun, revealing a wealth of golden artifacts and shedding light on ancient Egyptian burial practices. More recently, advanced scanning techniques have hinted at the possibility of hidden chambers within the Great Pyramid of Giza, promising future discoveries. In the Americas, the ancient Mayan city of Palenque in Mexico harbors underground wonders. Archaeologists discovered a network of water tunnels beneath the Temple of the Inscriptions, demonstrating the Mayans' advanced understanding of hydraulics and urban planning. These underground marvels continue to reshape our understanding of past civilizations, proving that some of history's greatest secrets lie hidden beneath the surface. Throughout Earth's history, our planet has experienced numerous catastrophic events, from massive asteroid impacts to supervolcano eruptions. These cataclysms have caused widespread destruction and mass extinctions on the surface. But what about potential civilizations deep underground? Could they have survived such devastating events? The idea of subterranean societies surviving global disasters is intriguing. Underground environments offer natural protection from many surface threats. Deep caves and caverns could shield inhabitants from extreme temperature changes, radiation, and atmospheric disturbances. They might even provide a buffer against shock waves from impacts or explosions. However, the challenges of sustaining a complex civilization underground are immense. Access to resources like food, water, and breathable air would be limited. Energy production and waste management would pose significant hurdles. Moreover, many catastrophic events, such as massive earthquakes or tectonic shifts, could still pose grave dangers to underground dwellers. While the notion of hidden underground civilizations surviving past cataclysms is fascinating, there is currently no scientific evidence to support such claims. If advanced subterranean societies ever existed, they would likely have left detectable traces. As we continue to explore our planet's depths, we may yet uncover surprising discoveries. But for now, the existence of such civilizations remains in the realm of speculation. Geologists and archaeologists work hand in hand to uncover hidden underground spaces that might serve as potential habitats. Geologists bring their expertise in rock formations, soil composition, and geological processes to the table. They use advanced techniques like ground-penetrating radar and seismic imaging to map out subterranean structures and identify promising areas for exploration. Archaeologists contribute their knowledge of human history and settlement patterns, helping to pinpoint locations where ancient civilizations might have created underground dwellings or structures. They analyze artifacts, study historical records, and employ cutting-edge dating methods to piece together the puzzle of past human activity in these underground spaces. Together, these scientists conduct careful excavations, taking care not to disturb the delicate balance of these environments. They meticulously document their findings, from the smallest pottery shard to large-scale cave systems. This collaboration often leads to remarkable discoveries, such as ancient cave dwellings, underground cities, or even natural caverns that could potentially support future human habitation. The insights gained from these joint expeditions not only shed light on our past, but also inform our understanding of how humans might adapt to living below the Earth's surface in the future. This knowledge becomes increasingly valuable as we explore options for sustainable living and potential off-world colonization. An underground civilization would encounter numerous obstacles in their quest for survival and progress. One of the most pressing issues would be food production. Without sunlight, traditional agriculture becomes impossible, forcing the civilization to develop alternative methods. They might turn to hydroponics or aeroponics, growing crops using nutrient-rich water solutions or mists. Fungi cultivation could also play a crucial role, as many fungal species thrive in dark, damp environments. Energy generation would present another significant challenge. Cut off from solar power and wind, the civilization would need to harness geothermal energy or develop advanced nuclear technologies. They might also explore chemical energy sources or attempt to tap into the heat at the planet's core. Air quality and circulation would be constant concerns. Without natural air currents, the civilization would need to engineer complex ventilation systems to prevent the buildup of harmful gases and ensure a steady supply of oxygen. Water management would also be critical, requiring advanced filtration and recycling techniques to maintain a sustainable supply. Perhaps the most profound challenge would be psychological. Living in enclosed spaces without natural light could lead to various mental health issues. The civilization would need to develop artificial light sources that mimic natural daylight cycles and create spaces that give the illusion of openness to combat claustrophobia and maintain their population's well-being. Despite these hurdles, an underground civilization could potentially thrive if they successfully adapt to their unique environment. Ancient civilizations left behind remarkable evidence of their mathematical prowess, challenging our perceptions of early human capabilities. The Babylonians, for instance, developed a sophisticated base 60-number system that allowed for complex astronomical calculations. Clay tablets from as early as 1800 BCE reveal their understanding of concepts we now associate with the Pythagorean theorem, predating Pythagoras himself by over a millennium. In Egypt, the construction of the Great Pyramid of Giza stands as a testament to precise mathematical understanding. Its near-perfect square base and alignment with cardinal directions demonstrate a grasp of geometry and astronomy that was far ahead of its time. The ancient Egyptians also developed a decimal system and showed proficiency in solving linear equations, as evidenced by mathematical papyri like the Rhind mathematical papyrus. The Mayans independently developed the concept of zero and used a vigesimal number system, base 20, which allowed them to make remarkably accurate astronomical predictions. Their long count calendar, capable of tracking vast periods of time, required a deep understanding of large numbers and complex calculations. In India, ancient mathematicians made groundbreaking contributions to the field. The Sulba Sutras, dating back to around 800 BCE, contain early discussions of irrational numbers and geometric constructions. Later, Indian scholars would develop the decimal system, including the concept of zero, which would revolutionize mathematics globally. These discoveries from diverse ancient cultures reveal a rich tapestry of mathematical knowledge that laid the foundation for modern mathematics. The astronomical precision found in ancient structures and artifacts continues to astound modern scientists and archaeologists. Many ancient civilizations, from the Egyptians to the Maya, demonstrated a remarkable understanding of celestial movements and incorporated this knowledge into their architecture and tools. One prime example is the Great Pyramid of Giza, which aligns with incredible accuracy to the cardinal directions. Its builders achieved this by using the positions of stars to establish a north-south line. Similarly, Stonehenge in England was constructed with precise alignments to solar and lunar events, suggesting its use as a sophisticated calendar. These achievements were made possible through generations of careful observation and record-keeping. Ancient astronomers tracked celestial bodies over long periods, identifying patterns and cycles. They developed mathematical systems to predict astronomical events and created instruments like the astrolabe to measure celestial positions. The motivations behind this precision were often a combination of practical needs and spiritual beliefs. Accurate calendars were crucial for agriculture and religious ceremonies, while alignments with celestial bodies were seen as connections to the divine. This blend of practicality and spirituality drove ancient societies to invest tremendous resources in creating these enduring, astronomically aligned monuments that continue to impress us today. Ancient civilizations possessed remarkable knowledge in various fields, including astronomy and mathematics. However, the idea that they understood physics beyond our current knowledge is not supported by evidence. While ancient cultures made significant observations and developed sophisticated calendars, their understanding was limited by the tools and methods available to them. The ancient Greeks, for instance, made important contributions to physics and mathematics. Archimedes discovered principles of buoyancy and levers, while Eratosthenes calculated the circumference of Earth with surprising accuracy. These achievements were impressive, but still fall within the realm of classical physics. Modern physics, including quantum mechanics and relativity, relies on observations and experiments that require advanced technology unavailable to ancient civilizations. Concepts like subatomic particles, dark matter, and the nature of spacetime were beyond their reach. Our current understanding of physics is built upon centuries of cumulative knowledge and technological advancements. That said, ancient civilizations often developed ingenious solutions to problems using the knowledge they had. Their achievements in engineering, such as the construction of pyramids or the development of sophisticated water management systems, showcase their practical application of physical principles. While they may not have surpassed our current understanding of physics, their accomplishments remain worthy of admiration and study. Throughout history, our ancestors developed various medicinal practices, many of which were dismissed as mere superstition. However, modern scientific research has validated several of these ancient remedies, proving that our forebears possessed valuable medical knowledge. One striking example is the use of willow bark to treat pain and fever. Ancient Egyptians and Greeks chewed on willow bark to alleviate these symptoms. Today, we know that willow bark contains salicin, a compound similar to the active ingredient in aspirin. This discovery led to the development of modern aspirin, now a staple in medicine cabinets worldwide. Another fascinating case is the use of honey for wound healing. Ancient Egyptians, Greeks, and Romans applied honey to wounds and burns. Modern studies have confirmed that honey possesses antibacterial properties and can indeed promote faster wound healing. Hospitals now use medical-grade honey for treating certain types of wounds and burns. The traditional use of garlic for its medicinal properties has also stood the test of time. Ancient civilizations, including the Egyptians, Greeks, Romans, Chinese, and Indians, used garlic to treat various ailments. Today, Scientific research has shown that garlic contains compounds with antimicrobial and cardiovascular benefits, validating its use in traditional medicine. Ancient civilizations possessed a remarkable understanding of chemistry and metallurgy, far surpassing what many might expect. The Egyptians, for instance, developed sophisticated techniques for creating alloys and working with metals as early as 3,000 years before the Common Era. They mastered the art of extracting gold from ore and crafting intricate jewelry, using methods that still impress modern metallurgists. In China, the discovery and refinement of bronze led to significant technological advancements. Chinese metallurgists were able to create precise alloys, combining copper and tin in exact proportions to produce tools and weapons of exceptional quality. This knowledge spread across Asia and eventually reached Europe, fundamentally changing the course of human development. The ancient Greeks and Romans further advanced these practices, developing new techniques for smelting and purifying metals. They created complex alloys and even understood concepts like oxidation, though they lacked the modern terminology to describe these processes. The famous Roman concrete, still standing in structures like the Pantheon, demonstrates their advanced understanding of chemical reactions and material properties. While these ancient chemists and metallurgists lacked the atomic theory and periodic table we use today, their empirical knowledge and practical skills were highly sophisticated. They laid the groundwork for modern chemistry and materials science, often through painstaking trial and error and keen observation of natural phenomena. Ancient civilizations developed remarkable technologies and scientific principles that continue to astound us today. The precision engineering of the Great Pyramid of Giza, for instance, demonstrates an advanced understanding of mathematics, astronomy, and construction techniques that we are still trying to fully comprehend. The ancient Romans created a form of concrete that has proven more durable than many modern varieties, especially in marine environments. Their recipe, which included volcanic ash, created a material that actually strengthens over time when exposed to seawater. This technology was lost for centuries and has only recently been rediscovered. In the realm of metallurgy, the Damascus steel used in sword making exhibited properties that modern scientists have struggled to replicate. These blades were known for their exceptional strength, flexibility, and ability to maintain a sharp edge. The exact technique for creating this steel was lost, though recent research has made strides in understanding the process. The Antikythera mechanism, an ancient Greek analog computer, reveals a level of mechanical complexity that was not seen again for centuries. This device could predict astronomical positions and eclipses with remarkable accuracy, suggesting a deep understanding of celestial mechanics and precision engineering in the ancient world. Throughout history, humans have marveled at the mysteries of the cosmos and sought to explain them. Ancient texts from various cultures often contain descriptions that seem to reference advanced scientific concepts. These apparent references can be intriguing, but they require careful interpretation. One explanation for these seeming advanced concepts is the human tendency to find patterns and meaning in ambiguous information. This phenomenon, known as pareidolia, can lead us to interpret vague or poetic language as precise scientific knowledge. Additionally, modern translations of ancient texts might inadvertently use contemporary scientific terminology, potentially skewing our understanding of the original meaning. Another factor to consider is the universal nature of human curiosity and observation. Ancient cultures, while lacking modern scientific instruments, were keen observers of natural phenomena. They developed sophisticated calendars, tracked celestial movements, and created complex mythologies to explain the world around them. These observations and explanations sometimes align with modern scientific understanding, not because of advanced knowledge, but due to logical deductions based on available evidence. It is also worth noting that some ancient cultures possessed remarkable engineering and mathematical skills, which could lead to descriptions that seem to surpass their technological capabilities. The challenge for historians and scientists is to distinguish between genuine ancient knowledge, coincidental similarities, and modern misinterpretations. By examining these texts in their historical and cultural context, we can better understand the true extent of ancient scientific understanding without attributing anachronistic knowledge to earlier civilizations. Creation myths across cultures offer diverse and fascinating explanations for the birth of civilization. Many of these stories share common themes, reflecting universal human curiosity about our origins and place in the world. In ancient Mesopotamian mythology, the gods created humans to serve them and tend to their needs. The Epic of Gilgamesh describes how the deities fashioned people from clay and breathed life into them. This idea of divine beings molding humans from earthly materials appears in several cultures, including ancient Egypt and some Native American traditions. Greek mythology presents a different perspective, with Prometheus stealing fire from the gods and gifting it to humanity. This act of divine rebellion is seen as the catalyst for human progress and the foundation of civilization. The concept of knowledge or technology being given to humans by a benevolent or mischievous entity is echoed in other cultures as well. Chinese mythology offers yet another view, with the story of Pangu, whose body became the world after death. In this tale, humans and civilization emerged from the natural world itself rather than being created separately. This interconnectedness between humanity and nature is a recurring theme in many creation myths, emphasizing our deep roots in the environment around us. Throughout human history, cultures across the globe have woven intricate tapestries of myths and legends, often featuring powerful deities and supernatural beings. These stories have long captivated our imagination, but could they be rooted in something more tangible than pure fantasy? Some researchers have proposed an intriguing hypothesis, that these legends might be distant echoes of encounters with an advanced pre-human species. This concept suggests that long before Homo sapiens emerged, Earth may have been home to a highly intelligent and technologically advanced civilization. Their abilities, far beyond those of early humans, could have appeared godlike to our ancestors. This advanced species might have possessed knowledge and capabilities that seemed miraculous to primitive humans. They could have demonstrated control over natural forces, harnessed energy in ways that appeared magical, or even manipulated genetic code. Such feats would have been indistinguishable from the supernatural powers often attributed to gods in various mythologies. As fascinating as this idea may be, it remains highly speculative. While it offers an imaginative explanation for the similarities in mythologies across different cultures, there is currently no concrete scientific evidence to support the existence of such an advanced pre-human species. Nonetheless, it continues to fuel discussions about the origins of human beliefs and the potential for undiscovered chapters in Earth's history. Mythical creatures have long captivated the human imagination and played a significant role in theories about ancient advanced civilizations. These legendary beings, from dragons to unicorns, often serve as the basis for speculation about the technological and cultural achievements of lost societies. Some theorists propose that mythical creatures were misinterpretations of advanced technology or biological experiments conducted by ancient civilizations. For instance, tales of flying serpents or dragons might be explained as primitive descriptions of aircraft or other flying machines. Similarly, stories of creatures with combined animal features could be seen as evidence of genetic engineering or selective breeding programs. Another perspective suggests that mythical creatures represent encounters with now extinct animals or exaggerated accounts of real species from distant lands. In this view, ancient civilizations might have had knowledge of or contact with creatures unknown to later societies, leading to the development of fantastic legends. However, mainstream archaeologists and historians generally reject these interpretations, arguing that mythical creatures are more likely the product of cultural imagination, religious beliefs, and the human tendency to create explanations for natural phenomena. While these creatures continue to fascinate, their role in serious scientific theories about ancient civilizations remains limited. Researchers approach stories of interbreeding between gods and humans as valuable cultural artifacts that offer insights into ancient belief systems and societal structures. These tales, found in mythologies worldwide, are not interpreted literally, but are analyzed for their symbolic meanings and cultural significance. Anthropologists and mythologists often view these stories as metaphors for the relationship between humans and the divine, or as explanations for exceptional individuals in a society. In some cases, they may represent attempts to legitimize ruling dynasties by claiming divine ancestry. These narratives can also reflect ancient understanding of natural phenomena or serve as moral lessons about the consequences of crossing boundaries between mortal and immortal realms. From a psychological perspective, such myths might be seen as expressions of human desires and fears about power, identity, and our place in the cosmos. They can embody collective unconscious archetypes, as proposed by Carl Jung, representing universal human experiences and aspirations. Comparative mythology scholars analyze similarities and differences in these stories across cultures, seeking to understand shared human experiences and the diffusion of ideas. By examining these tales, researchers gain valuable insights into the worldviews, social structures, and belief systems of ancient civilizations, helping us better understand our cultural heritage and the evolution of human thought. Throughout human history, myths and legends have often been used to explain the unexplainable. Some researchers and theorists have proposed that stories of magical or advanced abilities might be distorted memories of encounters with a technologically superior civilization. This idea, while intriguing, remains highly speculative and lacks concrete scientific evidence. Ancient myths often describe gods or heroes with extraordinary powers, such as flight, telepathy, or the ability to control natural forces. These abilities bear some resemblance to modern technological achievements like air travel, telecommunications, and weather modification. Proponents of this theory argue that ancient people might have witnessed or interacted with advanced technology, interpreting it as magic or divine power due to their limited understanding. However, mainstream archaeologists and historians generally attribute these myths to human imagination, cultural evolution, and the need to explain natural phenomena. They argue that similar mythological themes arise independently across cultures due to shared human experiences and cognitive patterns, rather than encounters with advanced civilizations. While the idea of ancient advanced civilizations continues to captivate the public imagination, current scientific consensus holds that human technological progress has been gradual and well documented. Nevertheless, ongoing research in archaeology and anthropology continues to uncover new insights into our past, reminding us that there is still much to learn about human history and the origins of our myths and legends. Flood myths appear in numerous cultures around the world, often sharing striking similarities despite vast geographical distances. These widespread tales have led some researchers to speculate about their origins and potential connections to actual historical events or lost civilizations. Many of these flood stories describe a great deluge that nearly wiped out humanity, leaving only a few survivors to repopulate the Earth. This common thread has prompted theories about a global catastrophic event in ancient times, possibly linked to the end of the last ice age. As sea levels rose dramatically during this period, coastal settlements would have been inundated, potentially giving rise to flood narratives passed down through generations. Some researchers have proposed that these myths might preserve memories of advanced civilizations lost to rising waters. The most famous example is the story of Atlantis, described by Plato as an advanced island nation that sank into the sea. While no concrete evidence of Atlantis has been found, the idea of lost civilizations continues to captivate the imagination and drive archaeological investigations. Importantly, while flood myths are intriguing, they should be approached with scientific skepticism. Many of these stories likely serve as metaphors or moral tales rather than literal historical accounts. Nevertheless, they continue to provide valuable insights into ancient cultures and their understanding of the world, as well as inspiration for ongoing research into human prehistory and geological events that may have shaped our ancestors' experiences. Many legendary creatures have roots in human attempts to explain natural phenomena or fossil discoveries. Dragons, for instance, may have originated from early human encounters with large predators or fossils of extinct creatures. Ancient peoples stumbling upon dinosaur bones could have pieced together imaginary beasts, combining features from various species to create the dragon myth. The concept of giants likely stems from similar origins. Discoveries of mammoth or mastodon bones, significantly larger than any known human or animal, could have sparked tales of humanoid creatures of immense size. In some cases, these stories might have been fueled by rare medical conditions like gigantism, where individuals grow to exceptional heights due to hormonal abnormalities. Interestingly, some animals that seem mythical do exist. The Komodo dragon, while not fire-breathing, is a massive lizard that can grow up to 10 feet long. The giant squid, long thought to be a sea monster, has been confirmed to reach lengths of up to 43 feet. These real creatures demonstrate how truth can sometimes rival fiction in the natural world. While many legendary creatures remain firmly in the realm of myth, they often reflect human curiosity about the unknown and our attempts to make sense of a complex and sometimes frightening world. Science continues to uncover new species and explain natural phenomena, sometimes revealing that truth is just as fascinating as legend. Theories of parallel universes and ancient advanced civilizations might seem unrelated at first glance, but they intersect in fascinating ways. Parallel universe theories suggest the existence of multiple realities beyond our own, each potentially with different physical laws or historical outcomes. This concept opens up intriguing possibilities when considering ancient civilizations. Some researchers speculate that if parallel universes exist, there could be alternate versions of Earth where ancient civilizations developed advanced technologies far beyond what we know from our historical record. These hypothetical societies might have harnessed energy sources or mastered space travel in ways we can only imagine. The idea of ancient advanced civilizations on our own Earth, often referred to as out-of-place artifacts or ancient astronaut theory, proposes that sophisticated societies existed in our distant past but left little trace. Parallel universe theories add a new dimension to this concept, suggesting that such civilizations might have existed not just in our past, but in alternate realities. While these ideas remain firmly in the realm of speculation, they encourage us to think critically about our understanding of history and the nature of reality itself. They remind us that our knowledge is limited and that the universe may be far more complex and mysterious than we currently comprehend. Time anomalies, while fascinating to contemplate, remain firmly in the realm of science fiction rather than scientific fact. However, the concept does prompt us to examine how we interpret archaeological findings and historical knowledge. Many artifacts or examples of knowledge that seem out of place for their time period often have more mundane explanations. These can include misinterpretation of evidence, contamination of archaeological sites, or simply gaps in our understanding of ancient technological capabilities. For instance, the famous Antikythera mechanism, an ancient Greek analog computer, initially seemed far too advanced for its time. Further research revealed that it was a culmination of existing mathematical and engineering knowledge, showcasing the ingenuity of ancient civilizations rather than evidence of time travel or anachronistic technology. In some cases, what appears to be advanced knowledge in ancient times can be attributed to independent discovery, cultural exchange, or lost technologies that were later rediscovered. The scientific method encourages us to seek the most plausible explanations based on available evidence, rather than jumping to extraordinary conclusions that lack supporting data. The concept of temporally displaced civilizations touches on fascinating areas of theoretical physics and cosmology. One principle that could potentially allow for such civilizations is the idea of closed time-like curves, a solution to Einstein's field equations of general relativity. These curves would theoretically allow for loops in space-time, enabling matter or information to travel backwards in time. Another relevant principle is the many worlds interpretation of quantum mechanics. This theory suggests that all possible alternate histories and futures are real, each representing an actual world or parallel universe. In this framework, civilizations might exist in different temporal states across various parallel timelines. Wormholes, hypothetical topological features of space-time, could also play a role. If traversable wormholes exist, they might connect two different points in space-time, potentially allowing civilizations to exist in different temporal locations. However, maintaining such wormholes would require exotic matter with negative energy density, which has not been observed in our universe. Lastly, the concept of time dilation in special relativity could lead to effective temporal displacement. A civilization traveling at speeds approaching that of light would experience time much more slowly than stationary observers, resulting in a form of time travel into the future. While not strictly creating temporally displaced civilizations, this effect could result in civilizations existing at different points along the cosmic timeline. Multiverse theories propose the existence of multiple universes beyond our own, each potentially governed by different physical laws and constants. In this vast landscape of possibilities, alternative evolutionary paths become not just plausible, but likely. Consider our own universe, where the delicate balance of physical constants allows for the formation of complex structures like atoms, stars, and ultimately, life. In other universes within the multiverse, these constants might differ slightly or dramatically, leading to wildly different outcomes for the development of matter and energy. Some of these alternate universes might foster conditions where life evolves along entirely different chemical pathways. For instance, in a universe with different carbon chemistry, life might be based on silicon instead. Other universes might see the emergence of life forms that are completely alien to our understanding, perhaps existing as patterns of energy or within exotic states of matter. The multiverse concept also allows for universes where evolutionary processes occur at vastly different rates or scales. Imagine a universe where time flows differently, resulting in billions of years of evolution occurring in what we would perceive as mere moments. These varied evolutionary paths across the multiverse showcase the incredible diversity and adaptability of life, even in its most hypothetical forms. Time travel remains a fascinating concept in both science fiction and theoretical physics. While our current understanding of physics doesn't rule out the possibility entirely, it presents significant challenges that even an advanced civilization might struggle to overcome. One of the main hurdles for backwards time travel is the grandfather paradox, where changing the past could create logical inconsistencies. Some scientists propose that if time travel were possible, it might follow the Novikov self-consistency principle, which suggests that any actions taken by time travelers would already be part of the timeline, preventing paradoxes. However, the energy requirements for time travel would likely be astronomical. Theoretical time machines, such as those using wormholes or cosmic strings, would require exotic forms of matter or energy that might not exist or be impossible to harness, even for highly advanced civilizations. If advanced civilizations have indeed mastered time travel, their absence in our timeline could be explained by strict non-interference policies similar to the Prime Directive in science fiction. Alternatively, they might be present but undetectable to us, observing without interacting. Ultimately, the question of time travel remains open, continuing to challenge our understanding of the universe and the nature of time itself. Quantum physics introduces fascinating possibilities when considering alternative historical timelines. At the quantum level, particles can exist in multiple states simultaneously, a phenomenon known as superposition. This concept has led some theorists to propose the idea of quantum multiverse, where different timelines or realities might coexist. The many worlds interpretation of quantum mechanics proposed by Hugh Everett suggests that every quantum event creates a branching of reality. In this view, all possible alternate histories and futures are real, with each representing an actual world or parallel universe. This interpretation could imply the existence of countless alternative historical timelines, each diverging at points where quantum events could have different outcomes. Quantum entanglement, another key principle in quantum physics, might also play a role in these theories. It describes how particles can be connected in such a way that the quantum state of each particle cannot be described independently, even when separated by large distances. Some speculate that this phenomenon could allow for interactions between different timelines or universes. While these ideas are intriguing, it is important to note that they remain highly speculative and are not widely accepted in the scientific community. The application of quantum principles to macroscopic events, like historical timelines, faces significant challenges in terms of evidence and testability. Nonetheless, quantum physics continues to inspire new ways of thinking about the nature of reality and the possibilities of alternative histories. The concept of cyclical time, found in various cultures around the world, presents an intriguing parallel to the idea of recurring advanced civilizations. This notion suggests that history and cosmic events repeat in grand cycles rather than progressing linearly. When applied to the possibility of advanced civilizations, it opens up fascinating scenarios. Imagine a universe where intelligent life evolves, flourishes, and then faces extinction, only for the cycle to begin anew. This pattern could theoretically occur on a single planet, with civilizations rising and falling over millions of years, or on a cosmic scale, with different worlds taking turns as hosts to advanced species. Some scientists have proposed that our universe might undergo cycles of expansion and contraction, known as the Big Bounce theory. If true, this could provide a mechanism for truly cosmic cycles of civilization, with intelligent life emerging in each new iteration of the universe. Each cycle could potentially last billions of years, allowing ample time for multiple civilizations to rise and fall. The cyclical view also raises profound questions about the nature of progress and knowledge. Would each civilization have to rediscover scientific principles from scratch, or could some information survive the cycle? The answers to these questions could dramatically shape our understanding of our place in the universe and the potential for long-term survival of intelligent life. Numerous cataclysmic events could potentially obliterate all traces of an advanced civilization. A global nuclear war stands out as a particularly devastating scenario. The immense destructive power of thermonuclear weapons, combined with the long-lasting effects of radioactive fallout, could annihilate cities, infrastructure, and even alter the planet's climate. The ensuing nuclear winter might trigger widespread ecosystem collapse, effectively erasing most signs of human achievement. Massive geological events pose another significant threat. A supervolcano eruption, like the one lying dormant beneath Yellowstone National Park, could blanket vast areas in thick ash, destroy cities, and plunge the world into a volcanic winter. This prolonged period of global cooling would devastate agriculture and potentially lead to the collapse of civilization as we know it. From beyond our planet, cosmic calamities loom as potential civilization enders. An impact event involving a large asteroid or comet could unleash energy equivalent to millions of nuclear bombs, causing global firestorms, tsunamis, and climate change. Such an event, similar to the one that likely led to the extinction of the dinosaurs, could wipe out most life on Earth, including any advanced societies. Lastly, a nearby gamma-ray burst, one of the most energetic events in the universe, could strip away Earth's protective ozone layer if directed at our planet. This would expose the surface to deadly levels of solar radiation, potentially causing mass extinctions and destroying many materials that serve as evidence of civilization. While some traces might survive these events, the combination of immediate destruction and long-term environmental changes could effectively erase most signs of an advanced society's existence. Scientists employ a variety of methods to study the effects of major impacts on Earth's history. One key approach involves analyzing impact craters, both on Earth and other celestial bodies. By examining the size, shape, and composition of these craters, researchers can deduce information about the impactor and the energy released during the collision. Geological evidence plays a crucial role in understanding past impacts. Scientists search for and analyze specific minerals and rock formations that form under the extreme pressures and temperatures associated with large impacts. These include shocked quartz, tektites, and iridium-rich layers in the Earth's crust. The presence and distribution of these materials can provide valuable insights into the timing and scale of ancient impact events. Advanced dating techniques are essential for placing impact events in the context of Earth's history. Methods such as radiometric dating allow scientists to determine the age of impact-related materials with remarkable precision. This information helps researchers correlate impact events with other geological and biological changes observed in the fossil record. Computer simulations and modeling have become increasingly important tools for studying major impacts. By inputting data about the size, composition, and velocity of potential impactors, scientists can create detailed models of how these events might have affected Earth's atmosphere, climate, and biosphere. These simulations help researchers better understand the long-term consequences of major impacts and their potential role in shaping Earth's evolutionary history. Gamma-ray bursts are among the most powerful explosions in the universe, capable of releasing as much energy in a few seconds as our Sun will emit in its entire lifetime. These intense bursts of high-energy radiation could indeed pose a significant threat to life on any planet unfortunate enough to be in their path. If an advanced alien civilization existed in our galaxy long ago, it is conceivable that a nearby gamma-ray burst could have had catastrophic consequences for their world. The intense radiation from such an event could strip away a planet's ozone layer, leaving the surface exposed to harmful ultraviolet radiation from its parent star. This could lead to widespread extinction of plant and animal life, disrupting entire ecosystems and potentially collapsing even a technologically advanced society. However, it is important to note that gamma-ray bursts are extremely rare events, and the likelihood of one occurring close enough to affect life on a specific planet is very low. Other cosmic events, such as nearby supernovae or extreme solar flares, could also pose threats to life, but their effects would generally be less severe than those of a gamma-ray burst. While the idea of an ancient advanced species being wiped out by a cosmic catastrophe is intriguing, we currently have no evidence of such an event occurring in our galaxy. The search for signs of past or present extraterrestrial civilizations continues, but for now, this scenario remains in the realm of speculation. Throughout Earth's history, there have been several major events that could have dramatically impacted human civilization or its precursors. One of the most significant is the Toba supervolcano eruption, which occurred approximately 75,000 years ago. This massive eruption is believed to have caused a global volcanic winter, potentially reducing the human population to a few thousand individuals. Such a catastrophic event could have easily wiped out any early civilizations, leaving little trace for us to find today. Another piece of evidence comes from the Younger Dryas impact hypothesis. This theory suggests that a comet or asteroid struck North America around 12,800 years ago, causing rapid climate change and mass extinctions. Proponents argue that this event could have led to the collapse of early human societies and the loss of advanced knowledge. Geological records also show evidence of massive floods that could have inspired flood myths found in many cultures. The flooding of the Black Sea basin around 5,600 BCE is one such event that might have had far-reaching consequences for early civilizations in the region. While these events provide tantalizing hints of past cataclysms, It is important to note that concrete evidence of advanced civilizations being completely reset remains elusive. The search continues as scientists and archaeologists work to uncover more clues about our distant past and the potential catastrophes that may have shaped human history. The speed of rebuilding after a catastrophic event would depend greatly on the nature and scale of the disaster, as well as the technological capabilities and resources available to the society. An advanced civilization with robust infrastructure and advanced technology might recover much faster than we might expect, based on historical examples. In the best-case scenario, with preparation and resilient systems in place, an advanced society could potentially restore basic services and begin rebuilding within weeks or months. Critical infrastructure like power, water, and communication networks could be quickly repaired or replaced using automated systems and advanced materials. However, full recovery would likely take years, even for a highly advanced civilization. Rebuilding cities, restoring ecosystems, and addressing the long-term impacts of the catastrophe would require sustained effort. The psychological toll on the population would also need to be considered, as trauma and societal disruption could slow the rebuilding process. Ultimately, the key to rapid recovery would lie in the resilience and adaptability of the society. Advanced artificial intelligence, nanotechnology, and sustainable energy systems could dramatically accelerate the rebuilding process compared to our current capabilities. But even with such technology, the path to full recovery would be a complex and time-consuming journey. Supervolcanoes have been significant players in Earth's long history, profoundly influencing our planet's climate and habitability. These massive geological features have erupted with such force and scale that they've altered global temperatures and atmospheric composition, leading to extended periods of cooling and environmental change. When supervolcanoes erupt, they release enormous quantities of ash, gases, and aerosols into the atmosphere. This material can block sunlight, causing global temperatures to drop dramatically. Such cooling events have triggered what scientists call volcanic winters, which can last for years or even decades. These periods of reduced temperatures have reshaped ecosystems, influenced evolution, and even contributed to mass extinctions. However, supervolcanoes have also played a role in enhancing Earth's habitability over long timescales. The gases and minerals they release can eventually lead to increased carbon dioxide levels, promoting a greenhouse effect that warms the planet. This warming has been crucial during Earth's recovery from extreme ice ages, helping to create more temperate conditions conducive to life. Furthermore, volcanic activity has been essential in recycling nutrients and minerals back to the Earth's surface. This process has enriched soils and oceans, providing the building blocks for diverse ecosystems to thrive. The interplay between supervolcanic eruptions, climate fluctuations, and nutrient cycling has been a driving force in shaping the habitable periods of our planet's history. Researchers employ sophisticated computer simulations and mathematical models to assess the potential impacts of doomsday scenarios on human civilization. These models integrate data from various scientific disciplines, including climatology, ecology, sociology, and economics, to create comprehensive projections of how catastrophic events might unfold. One common approach involves creating detailed virtual representations of Earth systems, including atmosphere, oceans, and landmasses. Scientists then introduce simulated catastrophic events, such as massive asteroid impacts or sudden climate shifts, into these models. By running numerous iterations with different variables, they can analyze how these events might affect global temperatures, weather patterns, food production, and other critical factors. Another crucial aspect of doomsday modeling involves studying historical data from past catastrophes, such as major volcanic eruptions or pandemics. This information helps researchers calibrate their models and make more accurate predictions about how modern society might respond to similar events. They also consider current technological capabilities, global interconnectedness, and societal structures to estimate resilience and recovery potential. Importantly, these models do not aim to predict the future with certainty, but rather to identify potential vulnerabilities and inform preparedness strategies. By understanding the possible consequences of various doomsday scenarios, scientists and policymakers can work to develop more effective mitigation and adaptation plans, potentially safeguarding humanity against existential threats. Archaeologists have unearthed several intriguing materials at ancient sites that continue to puzzle experts. One such enigmatic substance is the Damascus steel, renowned for its distinctive wavy pattern and exceptional strength. This legendary metal was used to forge swords of unparalleled quality, but the exact technique for its creation has been lost to time. Another perplexing discovery is Roman concrete, which has withstood the test of time far better than its modern counterpart. Despite centuries of exposure to seawater and harsh weather, many ancient Roman structures remain intact, showcasing the durability of this mysterious material. Scientists are still working to unravel the secrets of its composition and production methods. In South America, researchers have found evidence of an unknown substance used in Incan stone construction. This material, often referred to as the Incan cement, allowed massive stone blocks to fit together with astonishing precision, creating structures that have endured earthquakes and other natural disasters for centuries. Lastly, the presence of flexible glass in ancient Egypt has baffled historians and material scientists alike. According to historical accounts, this malleable glass could be bent without breaking, a property that defies our current understanding of glass technology. While no physical evidence of this material has been found, its mention in multiple ancient texts continues to intrigue researchers and fuel ongoing investigations into lost ancient technologies. The precision and durability of ancient structures continue to astound archaeologists and engineers alike. These remarkable feats of construction, some of which have endured for thousands of years, can be attributed to several key factors. First, ancient builders often employed sophisticated engineering techniques that were far ahead of their time. For instance, the ancient Egyptians used advanced surveying and leveling methods to achieve near-perfect alignment in their pyramids. They also developed specialized tools and equipment to cut, transport, and place massive stone blocks with incredible accuracy. The choice of materials played a crucial role in the longevity of these structures. Many ancient civilizations used high-quality, durable materials such as granite, limestone, and marble. These materials were often selected for their strength and resistance to weathering. In some cases, builders even created their own advanced materials, such as Roman concrete, which has proven more durable than many modern counterparts. Furthermore, the design principles employed in these ancient structures contributed to their longevity. Many incorporated features like corbelled arches, load-bearing walls, and precise interlocking stone blocks that distributed weight evenly and increased structural stability. These design elements allowed the buildings to withstand earthquakes, floods, and other natural disasters that would have destroyed less robust structures. While ancient civilizations made remarkable technological advancements, the idea that they developed materials superior to our modern equivalents is not supported by scientific evidence. Ancient peoples certainly created impressive materials and technologies for their time, but our understanding of materials science has advanced significantly since then. Ancient civilizations worked with materials like bronze, iron, and various types of stone, creating tools, weapons, and structures that have stood the test of time. The durability of some ancient constructions, such as Roman concrete or Damascus steel, has led to speculation about lost advanced knowledge. However, modern analysis reveals that these materials, while impressive, are not superior to their contemporary counterparts. Today, we have a deep understanding of atomic and molecular structures, allowing us to engineer materials at the nanoscale. We can create substances with precise properties, such as carbon fiber composites, that are stronger and lighter than any ancient material. Our modern alloys, ceramics, and polymers far surpass the capabilities of materials available to ancient civilizations. The perception of ancient superiority often stems from survivorship bias, where only the most durable ancient artifacts have survived to the present day. This can create a false impression of widespread advanced technology. In reality, our modern materials are more versatile, consistent, and capable of meeting a wider range of needs than anything available in ancient times. Several intriguing theories have emerged to explain how ancient civilizations constructed massive megalithic structures without modern technology. One prominent idea suggests the use of sophisticated levers and ramps to move and position enormous stone blocks. Proponents argue that these simple machines, when used skillfully, could have allowed relatively small groups of workers to maneuver stones weighing many tons. Another theory proposes that ancient builders might have used a form of concrete or artificial stone. This concept suggests that rather than quarrying and transporting massive blocks, some megalithic structures could have been cast in place using a mixture of limestone and other locally available materials. This method would have significantly reduced the labor required for construction. Some researchers have also explored the possibility of acoustic levitation, theorizing that ancient civilizations might have discovered ways to use sound waves to reduce the effective weight of heavy stones. While this idea remains highly speculative, it highlights the ongoing mystery surrounding these incredible structures. More conventional explanations focus on the ingenuity of ancient engineers in using sleds, rollers, and well-organized labor forces. These theories emphasize the remarkable planning and social organization required to complete such monumental projects, regardless of the specific techniques employed. Scientists employ a range of sophisticated techniques to analyze the composition of ancient materials. One widely used method is spectroscopy, which examines how matter interacts with electromagnetic radiation. By studying the unique spectral signatures of different elements and compounds, researchers can identify the specific components present in a sample without destroying it. Another powerful tool is mass spectrometry, which separates ions based on their mass to charge ratio. This technique allows scientists to determine the elemental and isotopic composition of ancient materials with remarkable precision. It has been instrumental in dating artifacts and understanding the chemical makeup of substances from long ago. X-ray fluorescence is yet another valuable technique. When bombarded with high-energy X-rays, atoms in a sample emit characteristic secondary X-rays. By analyzing these emissions, scientists can identify and quantify the elements present in ancient materials, from pottery shards to fossilized bones. Microscopy also plays a crucial role in compositional analysis. Advanced electron microscopes can reveal the microstructure and elemental distribution within ancient samples, providing insights into their formation and history. These methods, combined with careful interpretation and contextual understanding, allow scientists to unlock the secrets hidden within ancient materials, shedding light on past civilizations, geological processes, and even the early history of our planet. Archaeological discoveries have revealed surprising sophistication in ancient metallurgy and chemistry, challenging our assumptions about early technological capabilities. In ancient Egypt, metalworkers were crafting intricate gold objects with remarkable precision as far back as 3,000 years ago. They developed techniques for alloying and working with various metals, including copper, bronze, and later iron. The famous Damascus steel, produced in the Middle East from around 1,000 years ago, demonstrated advanced metallurgical knowledge. This steel, known for its distinctive wavy pattern and exceptional strength, involved complex forging and heat treatment processes that metallurgists are still working to fully understand today. In South America, pre-Columbian civilizations like the Incas showed mastery of advanced metallurgical techniques. They created alloys of gold and platinum, a feat that requires extremely high temperatures, which was thought to be beyond their technological means. This suggests they possessed sophisticated knowledge of metals and heat manipulation. Ancient chemistry is evident in the production of vibrant, long-lasting dyes and pigments, some of which have retained their color for thousands of years. The famous Egyptian blue pigment, for instance, was a complex synthetic material created through a multi-step chemical process. These examples highlight that our ancestors possessed far more advanced scientific and technological knowledge than we often give them credit for. While nanotechnology is often considered a modern scientific field, the concept of manipulating matter at the atomic and molecular scale has intriguing connections to ancient practices. Some researchers have found evidence suggesting that certain ancient civilizations may have unknowingly utilized nanotechnology in their craftsmanship. One fascinating example comes from the famous Damascus steel, renowned for its strength and sharp edge. Recent studies have revealed that this legendary metal contained carbon nanotubes and nanowires, which contributed to its exceptional properties. The ancient smiths who forged Damascus steel were unaware of the nanoscale structures they were creating, yet they had developed a process that produced these advanced materials. Another instance of potential ancient nanotechnology can be found in Roman glasswork. The Lycurgus cup, a 4th century artifact, displays an unusual optical effect. It appears green when lit from the outside, but glows red when illuminated from within. Scientists have discovered that this effect is due to the presence of tiny gold and silver nanoparticles embedded in the glass. The Roman artisans had inadvertently created a nanocomposite material, though they lacked the scientific understanding of their achievement. These examples demonstrate that while ancient civilizations did not possess the knowledge or tools to intentionally work at the nanoscale, they sometimes stumbled upon nanotechnology through trial and error in their craftsmanship. This unexpected connection between ancient practices and modern science highlights the ingenuity of our ancestors and the complex nature of materials they worked with, even without a full understanding of the underlying principles. Throughout history, ancient civilizations have left behind intriguing artifacts and structures that some researchers believe may contain hidden messages or advanced knowledge. The Antikythera mechanism, discovered in a shipwreck off the coast of Greece, is one such example. This complex bronze device, dating back to around 150 to 100 BCE, appears to be an ancient analog computer used to predict astronomical positions and eclipses. Its sophistication has led some to speculate that it might encode additional information about ancient Greek knowledge of the cosmos. In Egypt, the Great Pyramid of Giza continues to captivate researchers with its precise construction and alignment. Some theories suggest that its dimensions and placement encode mathematical constants or astronomical information. The pyramid's alignment with true north, accurate to within a fraction of a degree, has sparked debates about the advanced knowledge possessed by its builders. The Nazca lines in Peru present another enigma. These enormous geoglyphs, only fully visible from the air, depict various animals, plants, and geometric shapes. Some researchers have proposed that these lines might represent star constellations or serve as a form of communication with celestial beings, though these ideas remain highly speculative. In Central America, the Maya civilization left behind complex hieroglyphic writings and astronomical tables. While many of these have been deciphered, some scholars believe certain texts may contain additional layers of meaning or encoded information about Maya cosmology and mathematical knowledge that we have yet to fully understand. Researchers employ a variety of techniques to decipher and interpret potential ancient codes or languages. One key approach is comparative analysis, where experts examine known languages and writing systems from similar time periods or geographical regions to identify patterns and similarities. This method helped unlock the secrets of Egyptian hieroglyphs through the discovery of the Rosetta Stone, which contained the same text in 3 different scripts. Linguistic analysis plays a crucial role in decoding ancient texts. Researchers study the structure, grammar, and syntax of the unknown language, looking for recurring elements that might represent common words, prefixes, or suffixes. They also analyze the frequency and distribution of symbols or characters, which can provide clues about the nature of the writing system. Context is another vital tool in deciphering ancient codes. Archaeologists and historians consider the cultural, historical, and geographical context in which the text was created. This information can offer insights into the possible content and purpose of the writing, narrowing down the range of potential interpretations. Advanced technologies have revolutionized the field of ancient language decipherment. Computer algorithms can now process vast amounts of data, identifying patterns and connections that might elude human observers. These tools, combined with the expertise of linguists, archaeologists, and other specialists, are continually expanding our ability to unlock the secrets of long-lost languages and codes. Ancient civilizations have indeed left behind structures and artifacts that serve as unintentional time capsules, preserving information about their cultures, technologies, and ways of life. However, the concept of intentional time capsules as we understand them today is relatively modern. That being said, some ancient structures and artifacts do show evidence of deliberate preservation for future generations. The Great Pyramid of Giza, for instance, contains sealed chambers with boats, food, and other items meant to serve the pharaoh in the afterlife. While not intended as a time capsule in the modern sense, these chambers have provided invaluable insights into ancient Egyptian culture and technology. Similarly, the Dead Sea Scrolls, discovered in the mid-20th century, were carefully preserved in sealed jars within caves. Some scholars believe these texts were intentionally hidden to protect them from destruction, effectively creating a time capsule of ancient Jewish and early Christian writings. In a broader sense, many ancient monuments and structures can be seen as messages to future generations, encoding information about their builders' beliefs, knowledge, and achievements. The challenge lies in deciphering these messages and understanding the intentions behind them, as our modern perspective may differ greatly from the worldview of those who created these enduring legacies. Advanced civilizations seeking to communicate across immense spans of time would need to employ methods that can withstand the ravages of cosmic change. One approach might be to encode messages in extremely long-lived physical structures. Imagine monumental artifacts constructed from durable materials like certain ceramics or synthetic diamonds designed to persist for millions or even billions of years. These civilizations might also harness the power of stars to broadcast their legacy. By carefully manipulating the chemical composition of a star's outer layers, they could create distinctive spectral signatures that would be detectable by distant observers for billions of years. This stellar modification could serve as a cosmic lighthouse, signaling the existence of an advanced civilization long after it has vanished. Another intriguing possibility is the use of self-replicating probes. These sophisticated machines could be programmed to explore the galaxy, create copies of themselves, and carry messages across vast distances and timescales. As they spread throughout space, they would form a vast network capable of preserving and transmitting information over eons. Perhaps the most ambitious method would involve manipulating the very fabric of spacetime. Theoretical concepts like traversable wormholes or cosmic strings could potentially allow information to be sent backwards in time or preserved in stable configurations outside the normal flow of time. While highly speculative, such methods might offer a way to bridge even the most extreme temporal gulfs. Distinguishing between natural patterns and potentially meaningful designs in ancient artifacts requires a combination of scientific analysis and archaeological expertise. Researchers employ various techniques to determine if markings or shapes on artifacts are intentional or simply the result of natural processes. One key approach involves examining the regularity and repetition of patterns. Natural weathering or erosion typically produces random, irregular marks, while human-made designs often show consistent spacing, symmetry, or repeated motifs. Scientists use advanced imaging technologies like three-dimensional scanning and microscopic analysis to detect subtle details that might indicate deliberate creation. Context also plays a crucial role in this assessment. Archaeologists consider the artifact's location, age, and cultural background. If similar designs appear on multiple objects from the same time period or region, it strengthens the case for intentional creation. Additionally, researchers compare the artifact to known examples of art or writing from the same culture to identify potential similarities or symbolic meanings. Experimental archaeology, where researchers attempt to recreate ancient techniques, can provide insights into how certain patterns might have been produced. This hands-on approach helps distinguish between marks that could occur naturally and those requiring human intervention. By combining these methods, scientists can build a strong case for whether an artifact bears meaningful designs or simply natural patterns. Cryptography plays a crucial role in analyzing potential ancient messages, serving as a bridge between the past and our modern understanding. When scientists encounter symbols or patterns that seem to carry meaning but are not immediately decipherable, they turn to cryptographic techniques to unlock these secrets. One key application of cryptography in this field is frequency analysis. This method examines the occurrence of different symbols or characters in a message, comparing them to known language patterns. For ancient scripts or potential extraterrestrial messages, this technique can provide insights into the structure and possible meaning of the text. Cryptographers also use pattern recognition algorithms to identify repeating sequences or structures within ancient texts or signals. These patterns might indicate words, phrases, or grammatical rules, offering clues about the underlying language or code. Additionally, cryptographic approaches help in testing hypotheses about the nature of the message, allowing researchers to systematically explore different interpretations and decoding methods. Furthermore, modern cryptographic tools aid in the preservation and analysis of fragmented or damaged texts. By applying advanced algorithms, researchers can sometimes reconstruct missing parts of a message or clarify obscured sections, providing a more complete picture for analysis. This intersection of ancient mysteries and cutting-edge technology demonstrates how cryptography continues to be an invaluable tool in unraveling the enigmas of the past and potentially decoding messages from beyond our world. The possibility of overlooking messages from past civilizations is a tantalizing concept that continues to intrigue scientists and researchers. As we explore our planet and the cosmos, we must consider that evidence of ancient, advanced societies might be hiding in plain sight, waiting to be deciphered. One intriguing area of study is the examination of ancient structures and artifacts. Some researchers propose that certain archaeological sites, like the pyramids of Giza or the Nazca lines in Peru, could contain encoded information or serve as markers for future generations. These theories suggest that past civilizations might have left behind complex mathematical or astronomical data within the very architecture of their monuments. Another avenue of investigation focuses on potential extraterrestrial messages. Scientists have long searched for signals from space that could indicate intelligent life. However, it is possible that we have already received such messages but lack the technological sophistication or proper context to recognize them. Some researchers speculate that natural phenomena such as pulsars or even the cosmic microwave background could potentially contain embedded information from advanced civilizations. The challenge lies in our ability to recognize and interpret potential messages. Our own biases and limitations in scientific understanding might prevent us from seeing patterns or signals that are right before our eyes. As our knowledge and technology continue to advance, we may yet uncover hidden messages from past civilizations, both terrestrial and extraterrestrial, that have been patiently waiting for us to discover them. The Great Filter is a fascinating concept in the search for extraterrestrial intelligence. It suggests there might be a challenging obstacle that prevents civilizations from reaching advanced stages of development and expansion across the cosmos. This idea was proposed to explain why we have not yet detected signs of other intelligent life in our galaxy, despite the vast number of potentially habitable planets. The Great Filter could be a hurdle that occurs at any point in the evolution of life and civilization. It might be the difficulty of simple organic molecules forming complex life, or the jump from primitive to intelligent species. Alternatively, it could be a challenge that advanced civilizations face, such as self-destruction through warfare or environmental collapse. If the great filter lies in our past, it means humanity has already overcome a major obstacle, and we might be among the few civilizations to have done so. However, if the filter lies ahead, it could spell trouble for our long-term survival and expansion into space. This possibility adds urgency to our efforts to become a multi-planet species and ensure the long-term survival of human civilization. The concept of the Great Filter challenges us to consider our place in the universe and the potential paths of technological civilizations. It underscores the importance of addressing global challenges and pursuing sustainable development as we continue to advance as a species. The potential self-destruction of advanced civilizations is a compelling theory that addresses the puzzling lack of evidence for extraterrestrial life, often referred to as the Fermi paradox. This concept suggests that as civilizations develop increasingly powerful technologies, they may reach a critical point where they become capable of causing their own extinction. Consider the trajectory of our own civilization on Earth. We have progressed from simple tools to nuclear weapons and are now grappling with the challenges of artificial intelligence and climate change. Each technological leap brings both opportunities and risks. Advanced civilizations might face similar or even more extreme challenges, potentially leading to catastrophic outcomes. One possibility is that civilizations might develop weapons so destructive that they cannot be safely controlled, resulting in accidental or intentional annihilation. Alternatively, they could alter their environment so drastically that it becomes uninhabitable, much like our concerns about global warming, but on a more severe scale. Another intriguing aspect of this theory is the idea of technological singularity, where artificial intelligence surpasses human intelligence and potentially becomes uncontrollable. If this scenario plays out across the universe, it could explain why we have not detected signs of other civilizations. They might have been replaced or extinguished by their own creations before achieving the capability for interstellar communication or travel. Time is a relentless eraser of evidence, capable of obliterating even the most enduring structures and artifacts. Over millions or billions of years, geological processes such as erosion, tectonic activity, and volcanic eruptions can reshape entire landscapes, burying or destroying any traces of past civilizations. The materials used by a civilization play a crucial role in their longevity. Biodegradable or easily corroded materials might leave little to no trace after extended periods. Even seemingly permanent structures like buildings or monuments can crumble and disappear given enough time. A civilization that primarily used organic materials or those susceptible to decay would be particularly vulnerable to vanishing without a trace. Natural disasters pose another significant threat to the preservation of civilizational evidence. Catastrophic events such as asteroid impacts, supervolcano eruptions, or extreme climate shifts could potentially wipe out all signs of a civilization's existence. These events might not only destroy physical evidence, but also alter the planet's surface to such an extent that any remaining traces become unrecognizable or inaccessible. Lastly, the actions of the civilization itself could contribute to its disappearance from the historical record. A society that practices thorough recycling or reuse of materials might inadvertently erase its own history. Similarly, a civilization that experiences a gradual decline or chooses to minimize its impact on the environment might leave behind far fewer lasting traces than one that builds monumental structures or creates long-lasting artifacts. Theories of societal collapse typically focus on human civilizations, but they can offer intriguing insights when applied to hypothetical pre-human civilizations. These theories often highlight factors like resource depletion, environmental changes, social complexity, and technological overreach as potential catalysts for collapse. For a pre-human civilization, we might imagine similar pressures at play. An advanced species could face challenges managing limited resources on their planet, much like humans do today. They might struggle with the consequences of their own technological progress, perhaps altering their environment in ways that ultimately prove unsustainable. Social factors could also contribute to the downfall of such a civilization. Complex societal structures might become too rigid to adapt to changing circumstances, leading to internal conflicts or ineffective responses to external threats. The inability to maintain crucial knowledge or technologies across generations could result in a gradual decline of their capabilities and resilience. Interestingly, if such pre-human civilizations did exist and collapse, they might have left behind only the faintest traces for us to discover. This concept connects to discussions about the potential for lost ancient civilizations on Earth and the challenges of detecting signs of past intelligent life on other planets. Studying the rise and fall of advanced ancient societies offers valuable insights into human civilization and our potential future. These historical examples serve as mirrors, reflecting both our achievements and vulnerabilities as a species. One crucial lesson is the importance of sustainable resource management. Many ancient civilizations, like the Maya and Easter Island cultures, collapsed partly due to environmental degradation and resource depletion. They overharvested forests, exhausted soil fertility, and mismanaged water supplies. This reminds us of the delicate balance between human needs and environmental limits, a lesson particularly relevant in our era of climate change and ecological challenges. Another key insight is the role of social cohesion and governance in societal stability. The Roman Empire, for instance, began to decline when political corruption, economic inequality, and social unrest became widespread. This underscores the need for fair and effective governance, as well as social systems that promote unity and address inequalities. Technological innovation and adaptation also emerge as critical factors. Societies that failed to adapt to changing climates, new threats, or evolving trade patterns often faltered. Conversely, those that embraced innovation and adapted to new challenges tended to thrive. This teaches us the value of flexibility, continuous learning, and technological progress in ensuring long-term societal resilience and success. Resource depletion poses a significant challenge to the longevity of advanced civilizations. As societies progress and populations grow, the demand for resources increases exponentially. This heightened consumption can lead to the rapid exhaustion of vital materials necessary for sustaining technological advancement and maintaining quality of life. One of the primary concerns is the depletion of fossil fuels, which have been the backbone of industrial and technological growth for centuries. As these non-renewable energy sources dwindle, civilizations must adapt quickly to alternative energy solutions or face severe economic and social consequences. The transition to sustainable energy sources is crucial, but often requires substantial investment and technological innovation. Moreover, the scarcity of rare earth elements and other critical materials used in advanced technologies could hinder progress and potentially lead to conflicts. These resources are essential for manufacturing everything from smartphones to solar panels, and their depletion could slow technological advancement or even reverse it in some areas. Water scarcity is another pressing issue that could severely impact civilizations. As freshwater sources become strained due to overuse and pollution, societies may face agricultural crises, health problems, and increased conflict over this essential resource. Advanced civilizations must develop efficient water management systems and technologies to ensure long-term survival and stability. An advanced civilization might indeed have the capability to conceal its presence from others, effectively going dark and erasing evidence of its existence. This intriguing concept, often discussed in the context of the Fermi paradox, presents a fascinating possibility for why we have not yet detected signs of intelligent life beyond Earth. Such a civilization could potentially employ various methods to hide its presence. They might develop advanced cloaking technologies to mask their electromagnetic emissions, making them invisible to our current detection methods. They could also choose to limit their expansion and resource consumption, leaving minimal traces of their activities on a cosmic scale. The motivations for such concealment could be diverse. Perhaps they seek to avoid detection by potentially hostile civilizations or wish to observe less advanced species without interference. Alternatively, they might have evolved beyond our current understanding of technology and existence, operating on principles that inherently make them undetectable to our current scientific instruments. However, completely erasing all evidence of a civilization's existence, especially on a galactic scale, would be an immense challenge. Even with highly advanced technology, some traces might persist, such as subtle alterations to their home planet's atmosphere or long-lasting artifacts in space. The concept of going dark raises profound questions about the nature of advanced civilizations and the potential diversity of life in the universe.